You're watching NASA TV.
Good morning from the International Space Station Flight Control Room at the Johnson Space Center in Houston and Mission Control. As we begin our coverage today of U.S. Spacewalk 82, you are looking live inside the equipment lock of the Quest airlock of the International Space Station as the two astronauts who will venture outside the Quest airlock a short time from now. Josh Cassada, who is on the right side of your screen, wearing the suit bearing the red stripes, and just hidden from the field of view, Frank Rubio, who's on the left side, being attended to by Koichi Wakata from the Japan Aerospace Exploration Agency, and NASA astronaut Nicole Mann. There you see Rubio on the left. Those are our two astronauts for today who will venture outside for a spacewalk expected to last about 7 hours, the focus of which will be on the starboard fore truss of the International Space Station to install and monitor the deployment of one of the iROSAs, the ISS rollout solar arrays, one of two that were delivered on a SpaceX Cargo Dragon resupply craft last Sunday to the International Outpost. The spacewalk today is the 256th in support of space station assembly, maintenance, and upgrades. The third spacewalk that is scheduled for Expedition 68 so far this year. The 11th out of the International Space Station in 2022. Cassada and Rubio ventured outside back on November 15th for a 7-hour, 11-minute spacewalk in which they installed a so-called modification kit, basically a series of brackets on the starboard 6 truss of the International Space Station for a future spacewalk in which an iROSA, an ISS rollout solar array, will be installed for the 1B power channel of the International Space Station. That 1B channel will be a prime factor in today's spacewalk activities. We'll be talking more about that in just a second. The iROSA to be unfurled today to work in concert with its legacy solar array on the starboard fore truss, again delivered last Sunday on a SpaceX Cargo Dragon resupply craft, will be removed from a flight support structure on the truss of the station. It will be hand-carried by Cassada, who will be affixed in the manipulator foot restraints on the end of the space station robotic arm, the Canadarm2, and transported from the stowage position in which the array is located at the moment over to a bracket that was installed back in March of the International Space Station's spacewalk array to be installed on the starboard fore truss and then unfurled that ISS rollout solar array to work in concert to augment the electrical output of the 3A power channel of the International Space Station.
20 and number 22. We are in the 2-minute first time hold in step 20.
Concur with all these good numbers.
Nicole Mann reading out spacesuit readings back to Mission Control here in Houston. The crew is running about 10 minutes ahead of the timeline in their spacewalk preparations. They won't get too much further ahead of the timeline, though, deliberately, because all of the spacewalk work today is going to be timed out in explicit choreography to match the time that some of the work has to be done while we're in darkness or eclipse. That will match the time for the mounting of the solar array, its electrical connections, and ultimately the demating of one of 4 electrical connectors for the 1B power channel solar array that we'll talk about in just a second. Just to recap the bidding on the ISS rollout solar arrays, the original solar arrays, called the legacy arrays, although performing extremely well over the course of time, are showing some signs of degradation as expected. So to ensure a sufficient power supply is maintained for the International Space Station, NASA is in the process of augmenting the existing solar arrays and the power channels for the station accompanied by those new solar arrays. Ultimately, this will provide about a 20 to 30% increase in power for space station research and operations. The new arrays, the iROSAs, 2 of which have already been installed, today will be the third of 6 currently planned for installation. These new arrays will shade slightly over half of the length of the existing arrays and will be connected to the same power system, again augmenting and boosting the existing power supply for space station operations. The 8 current arrays, the original arrays, are currently capable of generating about 160 kilowatts of power during orbital daytime when the station is flying in daylight. Half of that power is stored in the station's batteries for use while the station is in darkness. Each new solar array, the iROSAs, will produce more than 20 kilowatts of electricity, eventually totaling about 120 kilowatts of augmented power during the time the station flies during orbital daylight. In addition, the remaining uncovered solar arrays and the partially uncovered original arrays will continue to generate about 95 kilowatts of power. So ultimately, we're going to wind up with some 215 kilowatts or so of power for the International Space Station. This is going to enable us to increase the amount of research and utilization in the future years of station operations. The ISS rollout solar arrays, again, this is the third in the series of 6 that are currently planned to be installed. The other 2 arrays that have already been installed are on the port side at the 1A and 1B power channels. Those are the ones that have already been installed. Today we're operating on the starboard 4 truss to install the power, the ISS rollout solar array to augment power for the 3A power channel. The next spacewalk that is scheduled for Rubio and Cassada is planned for December 19th. That will see them duplicate their efforts that they will undertake today, but this time on the port 4 truss of the International Space Station on December 19th, when they install a rollout solar array for the 4A power channel. Now, if time permits, at the back end of today's spacewalk activity, the crew will conduct one final important task, that being the demating of one of 4 electrical connectors on the neighboring starboard 6 truss where the 1B power channel solar array is located. About a week and a half ago, there was a power trip on that solar array very similar to what we saw back in March that reduced the power augmentation capability for the 1B solar array. About 10 days ago, when the latest power trip occurred, it took down the 1B channel altogether. The power output for the systems associated with the 1B channel are currently being taken over by the 1A power channel without any impact to station operations or any research activities aboard the station. However, in order to get that 1B power channel back up and running at some 75% of capacity, it will be necessary for Cassada and Rubio to demate one of 4 electrical connectors, very similar to what they'll be demating for the installation of the ISS rollout solar array during today's spacewalk. Once they demate that connector, the 1B power channel can be reactivated by the electrical systems officer here in Mission Control to get back to about 75% of its augmented capability, and that will bring the 1B power channel back online, albeit at a slightly degraded state, while it awaits the installation of its ISS rollout solar array to be delivered on a SpaceX cargo flight next year. If we can't complete either the complete installation and unfurling of the ISS rollout solar array for the 3A power channel today, or if we can't finish the demating of the electrical connector to enable us to reactivate the 1B power channel, then an additional spacewalk likely would be added this coming Wednesday, December 7th, that would see Cassada and Rubio venture outside once again to complete the work that they would not be able to complete at the end of today's excursion. However, we're expecting today's spacewalk to last about 7 hours in duration, and at least the plan going in is to get that iROSA for the 3A power channel fully deployed fully installed and deployed, and to demate that one electrical connector on the 1B power channel on the starboard 6 truss to enable flight controllers to reactivate the 1B power channel and get it up and running to 75% of its operating capability. As you watch Koichi Wakata of the Japan Aerospace Exploration Agency attach the equipment to Josh Cassada's spacesuit, he will do the same to Frank Rubio, who's on the left side of your screen a short time from now, this in preparation for the installation of the SAFER units, the Simplified Aid for EVA Rescue units, jet-powered backpacks that spacewalkers wear when they go out into the vacuum of space. That enables them in the highly unlikely event they would become untethered to propel themselves back to the safety of structure on the International Space Station. Both crew members will have their SAFER units attached, and then they will be moved one by one into the back section or the crew lock section of the International Space Station's Quest airlock. The hatch will be closed, and then plans will begin for the depressurization of the airlock in a two-step fashion, down to vacuum. First down to 5 pounds per square inch of pressure, then down to vacuum, prior to the time the crew would place their suits on battery power to mark the official start of today's spacewalk. A U.S.-based spacewalk out of the Quest airlock. Its elapsed time is measured from battery power on for the crew on their spacesuits to the time they're back inside and begin the repressurization of the airlock. Today's spacewalk, again, very intricate and very well choreographed to see the installation and unfurling of one of the two ISS rollout solar arrays on the 3A power channel, or the starboard 4 truss of the International Space Station, to boost the power capability for that power channel. We have an animation that is narrated by the lead spacewalk officer today, Chris Mundy, in which he will explain all of the work to be performed outside by Josh Cassada and Frank Rubio.
As the EVA begins, Josh Cassada as EV1 in the red stripes will egress the airlock first, followed by EV2, Frank Rubio, with the white stripes. They will each grab a bag, and then both crew members will translate out to a location on the truss to set up their tethers. EV1 will head to the iROSA carrier that has the stowed solar arrays to begin setting up that worksite by stowing his crew lock bag on a handrail and retrieving his pistol grip tool. EV1 will then release the first restraint bolt on the iROSA. Meanwhile, EV2 will head outboard to drop off their cable bag, then retrieve and stow their crew lock bag at the 3A iROSA mod kit. Back at the iROSA carrier, EV1 will retrieve an articulating portable foot restraint and install it on the end of the space station's robotic arm. EV1 ingresses that foot restraint, providing a stable platform to allow the iROSA to be carried from the carrier out to the mod kit installation location. Once complete at the mod kit, EV2 translates inboard and begins preparing the iROSA for removal from the carrier. First, EV2 will release 2 anti-rotation devices from the carrier. These devices secure the primary restraint bolts during the high vibration loads seen during launch. EV2 will then partially release the primary restraint bolts and install the first of 2 handling aids, called scoops, in preparation for removing the iROSA from the carrier. On the robotic arm, EV1 will fly over to access two sets of bolts on the boom end of the iROSA. The first two bolts will allow the boom deployment system rollers to be moved into place, later helping the arrays during deployment. The second two bolts will release two of four mechanisms holding the iROSA in its rolled-up configuration. The robotic arm will then fly EV1 over to the other side of the iROSA, and both crew members will work together to release the final bolt holding iROSA to the carrier. They will then install a second scoop, and then lift iROSA off of the carrier. After several maneuvers on the robotic arm, EV1 will arrive at the mod kit worksite. During these maneuvers, EV2 will reconfigure
Sharpie lights on the thermal cover.
Good news. Yeah, so you're go to open the thermal cover.
Coming open.
And for both of you, I wanted to let you know we're seeing good suit data here on the ground. Only thing we want to confirm is your suit P gauge.
P1 is showing 4.2. EV2 4.3.
Copy, guys. Thanks. And Josh, your go to Egress.
Copy that, Nick. Good. Go for the egress. Let's go install a new...
Josh Cassada will be first out of the Quest airlock, then will be joined by Frank Rubio as they gather all of their equipment before making their way over to the starboard fore truss.
Okay. Thanks, man. Yep. And Nick, did you cover? Did you copy my transmission about ICU is in the pouch?
Affirm. Thanks. And Josh, as you're coming out, you're looking to throw down your anchor hook on the aft D-ring.
Josh Cassada now outside of the Quest airlock. He is EV1, or extravehicular crew member number 1, wearing the suit bearing the red stripes. Frank Rubio will wear the unmarked suit, both crew members embarking on the second spacewalk of their careers.
Fighter lock, black on black. Moving over to port on 554 for Frank.
Copy, Josh. Gate close, fighter lock for your anchor. You'll just want to check your reels are unlocked. At some point, we can get that in the buddy checks. You're looking to put Frank's anchor hook on that port stanchion of 554.
Copy that. In work, and both reels are unlocked.
Copy. Thanks.
V2's anchor hook is gate closed, starter lock, black on black, port. Tether point there on the 554.
Copy, Josh. That's a good config. So, Frank, your go to release your waist tether, and you'll want to check that your reels are unlocked.
Okay, copy, unmarked.
And EV2, we just saw that your SCU popped out of the pouch.
Okay, yep, copy. Unfortunately, it was stuck between my legs, so I had to...
Nick, do you want me to go ahead and turn on my HECA? That's from EV1, sir.
Josh checking.
And I'm ready for the Tango bag when you've got it there, Frank.
Okay, A1.
And Josh, you've got to go to turn on your HECA.
Understand, HECA only right now for EV1.
Affirm.
All right, Josh, I am releasing my weight feather.
Copy. And HECA is on for EV1. I've got a green light.
Copy, Josh. Good green light on your HECA.
All right, Josh, and here is the Tango bag.
All right. Give me 1 second and I'll get a read on it. And I'm station aft. If there's any way you can persuade it this way. Okay, I got my hand on it. Stand by.
This is Mission Control Houston. Just to recap, the 256th spacewalk in support of space station assembly maintenance and upgrades underway, with the battery power on call from Cassada and Rubio coming at 6:16 a.m. Central Time, 7:16 a.m. Eastern Time. The two crew members in the process of moving outside of the Quest airlock. Once outside, they will make their way to the starboard fore truss to begin setting up all of their equipment and begin the work to detach the next in the series of ISS rollout solar arrays, or iROSAs, from a support structure on the truss of the station, and then manually move it over to the S4 truss, to which it will be installed on a mounting bracket, bolted into place, electrically connected, and unfurled to begin the augmentation of power for the 3A power channel on the International Space Station. This is, again, the third in a series of 6 currently planned solar arrays, augmented ISS rollout solar arrays, to be installed on the station.
Next step will be Frank coming out with the cable bag.
One additional task on tap for the two spacewalkers, should time permit, will be the disconnection at the end of today's spacewalk of one of 4 electrical cables on the neighboring starboard 6 truss for the 1B power channel that incurred a power trip about a week and a half ago, taking down some of the functionality of that array and placing the 1B power channel out of commission for the moment. Those loads being assumed by the 1A power channel for station systems without any interruption to station operations or research. However, to regain about 75% of the functionality of the 1B power channel, the 1 power connector at the end of today's spacewalk will be disconnected and isolated. It'll be capped off, basically, to isolate the affected area of the solar array for the 1B channel on the starboard 6 truss. Electrical systems officers will then reactivate the 1B power channel It, in of itself, will receive an ISS rollout solar array next year on the next pair of arrays that will be delivered on a SpaceX resupply mission. If time does not permit the two spacewalkers today to complete all of their work, then an additional spacewalk will be scheduled for this coming Wednesday, December 7th, to finish up either the deployment and activation of the ISS rollout solar array for the 3A power channel, or the disconnection of that one electrical cable to bring the 1B power channel back online.
Nick, as Frank is getting set up there, I do see his WVF is on, and I do not believe mine is. I don't see the light.
Okay, copy that, Josh. You can try to turn it on if you got a free hand.
I do. I stand corrected. I got 2 green lights.
Copy. 2 green. That's good.
Whether or not an additional spacewalk on December 7th is required, and again, we won't know that until we're done with the work today, Cassada and Rubio will venture back outside on December 19th to replicate the work they're doing today, but this time on the other side of the backbone of the station, on the port for truss of the International Space Station, taking yet another ISS rollout solar array from a parking place on the truss of the station and installing it on the 4A power channel original solar array on the P4 truss.
Look like they're in a great config.
Okay. And I'm feeling a slight pull, but I'm not seeing anything when I spin to the right. With my left foot. Interesting. I see no tethers.
Yep, I see you completely clear.
Okay. See water resistance.
Frank Rubio at the top of your screen, Josh Cassada on the bottom of your screen, still at the hatchway to the Quest airlock as the two crew members check and double check to make sure they have all their equipment before making their way over to the work site on the starboard 4 truss.
That is down, and your right one is done.
Okay.
Awesome. Thank you.
All right, with that, Nick, we've got everything except for HAP check. So my HAP is dry for EV1.
And my HAP is also dry for EV2.
Copy, guys. Good buddy checks. You're go to close the thermal cover.
Okay.
Your safety tethers there.
In work, and I'll clear those out.
Okay, and push.
Yeah.
Nice.
The HAP that you heard referred to by spacecraft communicator Nick Hague is the helmet absorption pad, making sure periodically throughout the spacewalk that there is no accumulation of condensation in the helmet. Everything looks good. The crew will now begin to translate or make their way over to the work site on the starboard 4 truss.
Otherwise, all looking good on your tethers. I see good checks.
Copy that.
Hey, guys. Okay, so
What do you think?
you're good. Frank, you're going to lead out, translate to the green hook location. Just remind you to put in a fair lead on handrail 500 and fair lead at the CETA spur.
I copy that. Pick that up my local and starting out. All right, Josh, I'll see you up there.
Sounds great.
And guys, as you're translating out, just want to let you know that was an on-time departure. Well done.
Nice. Great job by the IVs.
Yep, both on the team down on the ground and the one up here absolutely crushed it. Thank you, everybody.
I got a fair lead on 500.
Wonderful.
Can you give me a push on my bag there?
Yeah, for sure.
Why this TG?
For sure.
AT refuses to.
Yeah, sometimes that BRT seems like more like a suggestion, doesn't it?
All right, good.
Okay.
Thank you.
You got it.
Getting up to Cedarspur?
Copy.
Copy, Frank. You're going up to Cedarspur. For both of you, just a caution to avoid contact with the truss cable.
Thanks, Nick.
I think I'm at the top of the Cedarspur. I have a good, fairly.
Copy, Frank.
Thanks for that, Frank.
Come in. Hey, starboard.
Copy.
Copy, Frank. You're heading starboard. As you go out there, the handrail you're going to be looking for your green hook is 3215, 3215.
Copy. Nader station.
Okay, EV1 is at the rail, heading starboard.
I'm at the port feeder cart.
Okay. And Nick, understand mile marker 6300 is not a bad mark for me, is that right?
And we're checking.
That's okay. There's 6300.
And 6300 should be just above those handrails that are down on the nadir side.
Agreed. Thank you.
And Josh, your green hook, I didn't give you your handrail yet, but you know it's 3247.
3247. Great. That's where I am. Appreciate it. And making sure I stay Enos Franks. Agree with that, Nick? keep my safety tether zenith at Frank.
Yep, copy, Josh.
And like I am at the end of S1. And can you say again the handrail that I'm looking for?
Yeah, it's 3215, 3215.
V1's green hook is down on zenith end of 3247.
Nick, I am under the starboard feeder cart, and I see 3061, 3067. Can you vector me from here? I thought it was supposed to be kind of a diagonal handrail.
Yeah, Frank, if you look at the outboard edge of the CETA cart, your handrail is going to be zenith, kind of below mile marker 5820.
Copy.
V1's continuing up starboard a little bit. Frank, I will be nowhere near you when I off the feeder rail.
And Nick, I think I am at the end of my safety tether here.
Yeah,
because of the
Frank, copy.
fairleads.
Yeah, Frank, copy. So you're a little too far outboard. So the port CETA cart is what your target is. You're going to be on the starboard side of that port CETA cart, so you'll have to go back under the MT. When you get to that port CETA cart, your handrail is going to just be below mile marker 5820.
Copy. Josh, sorry about that.
Jeez, no problem, Frank.
I don't know why. I'm Doug. I could have sworn it was underneath the starboard seat of it.
No problem at all.
All right, Nick, I am on the nadir expansion of 3217.
And copy, Frank. Can you say that again?
I am on the nadir expansion of 3217. My green hook is dropped on the nadir expansion.
Yeah, copy that, Frank. 3215 is a little bit more nadir of that. It's the long handrail below it.
Okay, copy.
And while you guys are working into position, I'm going to read a couple warnings and cautions real quick. So warning to avoid the grapple shafts and cervic teeth. They're no touch. And then caution for no aggressive movements on the FSE, so less than 4 inches per second translation speed. Wait until any kind of motion dampens out before imparting loads, and you shouldn't impart loads simultaneously. And do not contact the iROSA blankets or solar cells. They're fragile.
ED1 copy.
ED2 copy.
ED1 is over Station Delta.
Yeah, and copy, Josh. You're translating toward the FSC tower handrail to stow the bag.
38 minutes into today's spacewalk, Cassada and Rubio making their way towards the ISS rollout solar array that is temporarily parked on a payload attachment device on the truss of the International Space Station. Rubio will be using a pistol grip tool to unbolt the first of a number of bolts that are available holding the iROSA in place. The release of the first of these bolts, plus the release of what are called anti-rotation devices that were designed to minimize the loads on the solar arrays in the trunk of the SpaceX Cargo Dragon carrier craft, the resupply vehicle that delivered this iROSA and a second iROSA to be installed on December 19th on the Port Fortress solar array of the International Space Station. These anti-rotation devices will be released, all part of the initial work to remove the iROSA from its support structure, its parking place on the truss of the station, prior to the time that Josh Cassada will then manually ride at the end of the Canadarm2 robotic arm to move the iROSA over to the starboard truss worksite, where it is to be installed on a mounting bracket for its installation and deployment.
All right, Nick, so my headset should be on now. Hit the WVS button. Power cycle it twice, and I did not see a green LED.
Okay, copy, Frank. HECA should be on now. We'll check it out, and you power cycle WVS.
There's no green light for WVS. I see a green light for HECA.
Okay, copy, green light for HECA, and we're seeing WVS.
Can I continue to the starboard seat, course?
Stay firm. You're going to stow that cable bag on the square grid alpha using 2 hooks to secure the bag.
While Cassada and Rubio are getting situated, making their way towards the iROSA that will be removed from its payload attachment device parking place on the truss of the station, Koichi Wakata and Nicole Mann are at the Destiny Laboratory robotic workstation as they begin to set up shop there. Wakata will be the arm operator driving Josh Cassada with the iROSA to the starboard 4 worksite for its ultimate installation.
All right, next bag is in a good spot there on the tower. I'm going to get my net off. We've got integral to forward expansion on the tower, and then the adjustable to 08, and that would be Zenith.
Yeah, we see it, and that's a great config, Josh. We'll take a glove and half check.
Sounds good. Let me put away my VRT, and then we'll do it. taking a look at my gloves. See no changes, but I'll hold them up to the hookup.
And Josh, we don't need the views.
Okay. All right, and the half is dry. So with that, I am ready for settings for R5.
Okay, copy that, Josh. Good gloves, good half. Your settings for the R5 bolt are going to be Bravo 2, counterclockwise 2.
All right, Bravo 2, counterclockwise 2 for R5.
That's a good read back.
Frank, where are you these days?
I am over on the starboard cedar code, dropping off the cable.
Awesome.
And Frank, once you get that cable bag tied down on the starboard seated carts, you're going to retrieve crew lock bag M plus that large small ret and stow it on your BRT.
Okay, that is work.
"46 minutes into the spacewalk, Rubio and Cassada soon to begin the first in a series of ongoing bolt-turning procedures. First to release the first of a series of bolts called R5 on the lower portion of the ISS rollout solar array that you see at the top of your screen. It is mounted on a attachment structure on the truss of the International Space Station after having been delivered to the station last Sunday on the SpaceX Cargo Dragon resupply flight to the International Outpost. The crew will also release the top portion of what are called anti-rotation devices. These are basically bolts that prevented any inadvertent movement of the iROSAs while they sat in the trunk of Cargo Dragon during its launch from the Kennedy Space Center.
Bag Mike with that large small ret, and you're heading over to the mod kit now. You'll want to check that your gauntlets are in place.
Yep.
Okay. Bravo 2, counterclockwise 2 is set, and we had a good test.
Okay, Josh, those are good settings. So you're going to release R5, expecting 18 to 20 turns. That bolt's going to spring out when released, and there should be a white line.
I'll be looking for the white line. Thanks for the reminder. 18 to 20 turns. Starting turn.
And the crew beginning the procedures and the release of the first of a number of bolts. There are some 36 bolts in all at a variety of areas along the ISS rollout solar array that must be released, both on the flight support equipment parking place on the truss of the station, on the iROSA itself, and then ultimately to bolt the iROSA in place on its modification kit or bracket to which it will be affixed on the starboard fore truss of the station.
Yeah, there's 18 and no white line yet. Stand by. Well, it is popped out. Is there a chance this white line is fairly subtle and hard to see from my vantage point?
Okay, Josh, copy. You got 18 turns and that popped out.
I'm negative. I got a total of 20 now. I did 2 additional, and I can see, you can probably see my camera here. It is popped out, and I just a little hard with the sun here to see if there's a white line.
Copy, Josh.
You guys have good? Do you have good video on that?
And negative. We don't have KU right now.
Oh, fine.
But Josh, you've got the number of turns, and if it popped out, we're good to press.
Okay. I think the white line is pretty subtle. I see it at the base, I believe. It's slightly different than the shaft of the bolt.
Copy, Josh. We're go to press. Everybody's happy.
Copy.
All right, Nick, I am at the pocket, and I have the large, small reds to the left mid-strut handrail, and then I have the integral to the left lower strut, lower stanchion handrail, or handrail lower stanchion.
Yeah, copy that, Frank, and we'll take a glove, tap, and gauntlet check.
Copy that.
And guys, while I've got a second, I'm going to give you some cautions for the mod kit. No sudden movements on the mass canister or mod kit, less than 4 inches a second on the BGA to translate slow. Avoid cyclic loading, and be mindful that the IEA battery AP cables are a snag hazard.
Okay, copy that. Thanks.
52 copies.
All right. I understand I'm going back to the feeder cart. Is that correct?
That's a firm, Josh. When you're ready, you're going to move to the port feeder cart with 3.
Port feeder cart with 3.
Nick, while I'm out here, the pocket looks good. We have 3 soft captures in the right position and no fraud on the platform.
That's awesome. Thanks. Appreciate the check. Next step is going to be translating back to the FSC.
Okay. Good work.
Flying from southwest to northeast across the Pacific, soon to cross the west coast of South America. The International Space Station flies smoothly on. 53 minutes into today's spacewalk by Josh Cassada and Frank Rubio, running about 15 minutes ahead of the timeline so far, having begun the spacewalk at 6:16 a.m. Central Time, 7:16 a.m. Eastern Time.
All right, Frank, I'm at the Post-EVA cart. I can imagine a little bit of a traffic jam here.
Okay. See you. Are you about to head back anytime soon?
I'm getting an APFR in now. Okay. All right, Nick, I'm currently showing top up, top off. And looks like must be Fox 6 already, so it's just the clocking that will have to change.
Yeah, your current setting, Papa Papa Foxtrot 6, is what you're going to install. When you do the install, it's clocking 12.
And Nick, if I had Zenith here, my safety tether will go up and up. You guys want me to wait here, or is that okay?
Copy, work.
Hey, Frank, understand, and we've got a good view of kind of the bottleneck that we've got going on. Big picture for you guys, we're over 7 hours on consumables. We're up 15 minutes on the timeline. You guys are going great. So, Frank, if you just want to hold position while Josh works this, and then we'll let you pass through.
Okay, sounds great.
While you're hanging out there, if you want to give us a glove and half check, that'd be great.
Apologies, I owed you one. All right, so get my gloves. I have a couple of tiny nicks on the rubber part, but absolutely superficial, otherwise baseline, and dry hat.
Good ret to the APFR, and put on my VRT.
Copy, Frank. Understand. Good glove and hat.
Affirmative.
Light on black and removing. APFR is uninstalled. All right. And since you're there, you can probably see I'm going to try to stick this out the side. It's probably the best way to translate, if you agree. It's going to clear stuff.
Yep. It's going to hit the brake lever, but I think it'll stay, it'll bump into the brake lever, basically.
Got it. Thank you.
Need a little bit more inboard just to keep it from catching. There you go. You're good. Okay, continue inboard as much as you can. And click you are clear of the brake handle.
Awesome. Thank you. That was super helpful. All right. That is your departure point for any of the FSCs, so I'm out of your way now.
Okay. Awesome. Thank you.
And Josh, as you head inboard toward FHRC, you're looking for mile marker 6300, 6300.
One's my favorite. Thanks, Nick.
And Frank, you're going to translate up to the tower handrail. You're going to go stanchions Alpha Bravo Charlie to the tower.
Okay, copy. Thank you. Okay, I'm looking for a robotic arm around here. That's the one. All right, Frank, do you need comp? Negative, thank you. M1, M2, on Spaceground 1.
Hello, EV1. We have a GCA to published APFR install position on your go.
Okay, EV1 is ready GCA to the APFR install position.
With the first of the numerous bolts having been released by the crew at the 1 hour mark into today's spacewalk, bolts holding the iROSA or the ISS rollout solar array in place on the attachment device on the truss of the International Space Station. Josh Cassada will soon retrieve an articulating portable foot restraint that he will attach to the end of the station's robotic arm that will be operated by Koichi Wakata from the robotic workstation with the assistance of Nicole Mann in the Destiny laboratory of the complex. Cassada will plant his feet in that articulating portable foot restraint. He will ultimately carry the iROSA over to the starboard 4 work site like a telephone repairman at the end of a cherry picker. And he and Rubio will then begin the work to install the iROSA, bolt it into place, and prepare it for its ultimate unfurling.
Okay, we are at the published position.
Understood. Stand by. Okay. I think that's going to work. Let's call it GCA complete, and I'll let you know if I need anything else.
Copy. GCA complete. Brakes are on. Go for APFR install.
Understand. Go for APFR install. And I am going to put my anchor over on the SSRMS handrail, and that's a local dismount. I'll do the tether swap later.
And Frank, you're going to retrieve that PGT from crew lock bag Tango and put that on your swing arm and head over to stanchion Bravo.
Affirmative, inward. And Nick, did you copy? I'm just going to local to the arm itself for the install.
While Cassada is in the process of retrieving and installing the articulating portable foot restraint at the end of the robotic arm, Frank Rubio will begin to release the anti-rotation devices. Again, these are devices that prevented any inadvertent motion by the delicate ISS rollout solar arrays while they were in the trunk of the Cargo Dragon, the SpaceX Cargo Dragon that delivered the arrays to the International Space Station, preventing any inadvertent loads to be placed on the iROSAs during their transit, during launch and ascent.
If you want to check it before you stick it in.
Copy that. Thank you. Nick, I have the PGT in hand. There's 2 reds on it. I have 1 red now to my mini workstation to tether the PGT to me. Can I release the other one to the bag?
Yeah, Frank, the plan is to leave that red external to the bag, so yeah, you can release it to the outside.
Thank you. Hi, Nick. I have a PGT. I'm en route to Romeo 5. Josh, you got me?
I do have it. A lot of tethers out here, Frank. I'm looking forward to getting down to one.
Dude, I can't imagine having all that stuff under. You're doing great with it, though.
And Nick, EV1, how do you hear? M2, EV1, how do you hear?
Hey, and Josh, I've got both you and Frank.
Okay, sounds good.
Okay. And Nick, did you copy my last time? The PGT, I'm en route to Romeo 5.
Yep, copy, and I see you in motion.
Okay. Just be advised, we didn't copy your response.
Okay, copy that.
And M2, EV1, you hearing us okay?
Hey, Farm, we're hearing him loud and clear.
Also had one this one with you as well, just a heads up. Now you have more of that ratty cough.
Yep.
On the right side of your screen, wearing the suit bearing the red stripes, Josh Cassada with the articulating portable foot restraint that he will attach to the end of the station's robotic arm. That soon will be operated by Koichi Wakata with the assistance of Nicole Mann from the robotic workstation inside the Destiny Lab. A good view in the middle of your screen of the ISS rollout solar array that will be released from its attachment point, its temporary parking place on the station, and then maneuvered into place to be installed on a mounting bracket, a mod kit, if you will, that was installed on the station during a spacewalk last March.
Copy, Frank. It's Bravo 2, counter 2.
Copy, Bravo 2, counter 2.
That's a good readback. You're going to expect 18 to 20 turns. The bolt's going to pop out when fully released, and there should be a white line.
Okay, copy that.
This is the procedure for Rubio to release the R5 bolt, the first in the series of bolts holding the iROSA rollout solar array in place on its temporary parking spot on the truss of the station.
Okay, black on black, good pull and truss test. And I'm going to grab my rep.
Yeah, copy that, Josh. And can you check the pitch knob?
Oh, yeah. Oh, this one's better than the last one. It can be pressed.
Looks great. We see it.
EV1, and we have a GCA to publish APSR Ingress position when you're ready.
Copy that. In the maybe 5 minutes or so, we'll do a tether swap here.
Yep, copy that, Josh. That tether swap's the next thing.
Copy. All right, once I'm ready for that, Nick, I was going to drop the left anchor hook, my left safety tether first, and then work on the red. Are you okay with that?
Yeah, we'd like you to work the arm side first. And Josh, I think you were just talking about your local.
No, I'm actually talking next step here. I'll put my left safety tether anchor on the FSRMS handrail. This point.
Those are good words.
Yeah, sounds good. Thank you. I think I have 20 turns on Romeo 5, and I see white line.
Copy, 20 turns and a white line. So you're good to translate to Charlie 2.
Copy, Charlie 2. Okay, left safety tether is connected to the SSRMS tether point. In fact, I'm going to move it to the other one. Stand by. Okay. Left safety tether anchor is on the SSRMS business end. Handrail tether point, gate closed, fighter lock, black on black. That 85 foot is unlocked, and the red and white crew hook is on my left D-ring center, gate closed, fighter lock, black on black.
Copy, Josh. That is a good configuration.
Understand next steps are lock the red reel and put the red hook on the feeder rail. Is that correct?
Hey, firm. You'll just want to keep an eye out for Frank's tether.
It is nadir of me, so I'm going to call that good, but thank you for the reminder. All right, red hook is coming off the right side. And it is at 6,300, and red reel is unlocked.
Copy that, Josh. That's a good tether swap.
All right. I'm going to grab my locals off of the arm, and then you agree, Matt. I see us getting into the GCA.
Hey, firm, Josh. That's the next step is GCA for the Ingress position. And Frank, when you're in position for Charlie 2, you're going to attach the adjustable equipment tether from your small trash bag to the ARD tether point.
Okay, that's complete. I'm ready for settings for ARD Charlie 2.
Bravo 3, counter 2.
Bravo 3, counter 2.
That's a good readback, and you'll release 6 to 10 turns.
Okay, copy that. And after I get this one out, I'll drive it back, and then I'll go to ARD 1. I'm good. EV2 is good on comms.
Okay. Stand by. I'm going to bring that Ingress 8 in a little bit to give you a little bit of clearance when we come station nadir.
Appreciate it.
Okay. If you're good on comm, Frank, I am going to take it for a GCA.
You're good. I'm good on com. Thank you.
All right, EV1 is ready, GCA, and as a heads up, M1, looks like about 6 inches from the front of the APFR to the structure. I'll keep it clear.
Copy, that's what we expect.
Rubio now in the process of releasing these anti-rotation devices, the bolts that basically secured the ISS rollout solar array in place in the trunk of the SpaceX cargo Dragon that carried this and another ISS rollout solar array to the International Space Station, arriving last Sunday. These ARDs are anti-rotation devices designed to prevent any inadvertent loads being placed on these delicate arrays until they arrived at the station for their installation. In this case today, with the first of these 2 solar arrays on the starboard fore truss of the station for the 3A power channel.
Good motion. We're clear.
Ramping out motion. Okay, that's our published position.
Okay, GCA complete.
Copy, GCA complete. Brakes on, go for APFR Ingress.
Copy, go for APFR Ingress.
And Frank, just want to point out the white string that's across the top of that ARD, that large loop. It's there to help if you need it to pull straight out from the ARD if you've got that block rotated out of the way.
The block kind of keeps floating back into where it's blocking it, unfortunately. I put 9 turns in, so it should have plenty of room.
Yeah, if the block rotates, then that's good. As long as we can keep it out of the way, then the ARD should just pull straight off the bolt.
It's off.
Well done.
Okay, I'm ready for settings for driving it back.
Yep, to drive that back, it's going to be Bravo 1, clockwise 2.
Bravo 1, clockwise 2. Copy.
Yep, and you're going to drive that to torque and give us the turns and light.
Copy.
One hour, 18 minutes into the spacewalk. You're looking over the shoulder of Frank Rubio as he continues work to drive bolts that have held the ISS rollout solar array in place on an attachment point on the truss of the International Space Station. There are a number of bolts for a variety of different mechanisms that must be loosened and backed out of their installed position in order to enable Josh Cassada to move the array to the work site at the starboard fore truss for its installation.
You want me to drive it back out and reset it, or leave it as is?
Checking.
At the current setting, I had, or at the current position, I had 11.8 torque, 4 turns, green light.
Yeah, copy 11.8 on the torque. Didn't copy the turns, but you got a good green light.
4 turns.
Copy 4 turns. Checking.
And Nick, understand where to go for the back off?
That's affirm, Josh. Your go.
Okay, we're set up here, EV1. This is going to be body out and body down. We're coming out about 1 meter and down 3.5 meters.
Out 1 and down 3 meters. EV1 copies. Thanks. You have a go.
Starting motion.
Nicole Mann orchestrating the movement of Josh Cassada now, who is affixed at the end of the station's robotic arm to position him for his next work.
And Frank, we're happy you can press to the other ARD.
Okay, copy.
Okay, there's your X, and now we're coming station data.
EV1 copies.
Good view of Josh Cassada at the end of the Canadarm2 robotic arm in a foot restraint, positioning him at the right orientation. He will be rotating a couple of rollers called boom deployment system rollers 90 degrees to a deployed position, part of the work in tandem with Frank Rubio to release the ISS rollout solar array from its parked position on the truss of the station.
Okay, EV1, we are at the published back-off position. We are setting up for a 2.5 minute bolt access joint OCAS.
EV1 copies.
And a panoramic view from 260 miles above the Earth as the International Space Station passes off the northwest coast of Spain.
Stand by. Okay, I'm ready.
Starting motion. Okay, maneuver complete. Setting up for the joint OCAS.
Okay, copy that. Got it. It briefly looked like body right motion on that last one, just a heads up. Might have been just me swaying here. Frank, how are those ARDs working for you?
Oh, good. Yeah. A little more challenging than I expected, but.
EV1, we are ready for the joint OCAS. This is going to pitch you back 90 degrees and bring you underneath iROSA.
EV1 copies. Here we go.
3, 2, 1, starting motion.
I see good motion, a little body left and towards my back.
Nick, I am at ARD1. I am ready to it, and I'm ready for settings.
Copy. We see the same, Frank. Bravo 3, counter 2.
Bravo 3, counter 2. Copy.
That's a good readback. Again, 6 to 10 turns until you can rotate that stop block.
Copy. Thank you.
Okay, Nick, I've got...
We will be regaining our downlink video from the station momentarily, handing over communications between satellites on the tracking and data relay satellite system.
Got it. It's probably too early to tell how much of the maneuvering out to S4 will be at night. Is that right?
Motion's ramping out.
Understand. Motion is stopped.
Yeah, just we checked the timeline, and you should be in a night pass when you're maneuvering out.
Copy. All right, Nick, unfortunately, I've got 10 turns in there, plenty of clearance between the block and the ARD, but the brand here snapped while I was trying to pull it out.
Copy, Frank.
EV1, we're setting up for GCA to publish R1, R2 bolt access.
Okay, sounds like they might be at the comm. Nick, I'll let you decide on if you want us to GCA here or stand by.
I just got it off.
Need any more comm, Frank?
I'll just verify settings for putting it back in, please.
Yep, Frank, it's going to be Bravo 1, clockwise 2, and then we're going to need the torque and turns.
Bravo 1, clockwise 2, copy, thank you.
Before we do the GCA for me on R1, R2, is it Alpha 2 counterclockwise 2? Just to get that set up as we move.
It's Alpha 4, counter 2.
Alpha 4, counter 2, I'll get it set up. D1 is ready, GCA to published for R1, R2 access.
Okay, we are ready. This will bring you body in about 1.5 meters.
Copy, body in, 1.5 meters.
Starting motion.
Approaching the 90-minute mark in the spacewalk, Frank Rubio continuing to back out bolts to release anti-rotation devices. Basically, these are devices holding the ISS rollout solar array in a stable position. That's what they were used for during the launch and ascent of the arrays in the trunk of the SpaceX Cargo Dragon. Josh Cassada at the end of the station's robotic arm, being carefully maneuvered by Koichi Wakata under the watchful eye of Nicole Mann, who's working with Wakata at the robotic workstation in the Destiny Laboratory as he begins work to unbolt 2 bolts for the deployment boom deployment system. These are restraint bolts.
0 centimeters to go.
The boom deployment system to be employed later as the ISS rollout solar array is unfurled to its full length of 60 feet once it is installed and electrically connected to the 3A power channel on the starboard fore truss of the station.
You're on copy, stand by. published position is going to work fine. It's GCA complete.
Copy. GCA complete. Go for unbolting.
Go for unbolting R1, R2. Nick, I've got Alpha 4 counterclockwise 2 set for R1.
That's a good setting. 10 to 13 turns, and the bolt's going to spring out when fully released. Just a caution when you rotate those booms to do it slowly, 90 degrees in 10 seconds.
Copy that. 10 to 13 turns, starting now.
Good view looking right down the barrel of the ISS rollout solar array. These are boom deployment restraint bolts that Cassada is backing out, so that there are two rollers that will be rotated 90 degrees to assist in the freeing up of the ISS rollout solar array from its parked position.
Okay, copy that.
And verify I'm doing a...
Yeah, Frank, you're going to do the socket swap, so you're going to grab that socket caddy.
10 turns for R1.
Copy inward.
And there's
I'll
that
do the same on R2 and then swing them out. That was 10 turns. It's popped out.
Copy, Josh. 10 turns and it popped out. And Frank, the socket caddy, there's that red on the external that you can use to stow that socket caddy on the outside.
Okay. Yeah, I appreciate that. It looks like it's fine here.
Just want to confirm counterclockwise R2.
Counterclockwise for R2. Alpha 4 counter 2.
You got it. Counter, same direction. Here it comes. Turns. R2 is popped out.
Copy, Josh. We see 10 turns and we see a good bolt release. And so, Josh, once you stow your PGT, you'll rotate those booms down slowly.
Sounds good. I'll do it. Thank you. You are looking good over there.
Pretty sweet view of the moon up here.
Make that space look good. I know, I saw that. That's an incredible view. Hey, I don't know if you'll be able to see it, but at some point in this whole process, if you're able to get as comfortable with this APFR ingress as I am, if you can see that I'm all the way in, that would feel really good.
Okay.
All right, 10 seconds for 90 degrees on R1.
Copy, Josh.
All right, Nick, I have the 12-inch 5/8 on my PGT, good pull test, and I have the 7/16 12-inch on the caddy, good pull test.
Copy, good socket swap. Thanks, Frank.
Verify I'm heading over to Charlie 1.
A firm, Charlie 1, next to stanchion Charlie.
Okay. I'm going to head over to Delta real quick and give Josh the system APFR. Josh, I see your right foot.
I think the official term is warm fuzzy.
Yeah.
I think that's what you're looking for.
You got a warm fuzzy on your right.
Okay.
Your left, if you take your heel just a little more outside, can you turn it anymore? No? Okay, then you're in a good position. I can only see the inside, and it's on the edge. Okay. I think it's just large heels.
Sounds good. You know what? You also have a great view when you're over at C2.
Okay, sounds great.
Thank you so much. Okay, I've got R1, R2 arms at least all the way swung out.
Copy. Good rotation on both those booms.
Okay, for R3, R4, I know one of them is the other direction.
Yep, copy. R3 and R4 is going to be the next step, and you need to assess your position, see if you need any GCA to be able to reach those.
You know what, M1, do you mind if we took a minute and just moved the body down? It'll just help since I've got about 500 of these to do or so.
1 hour 35 minutes into the spacewalk, Josh Cassada has released the first in a series of bolts for the boom deployment system on the ISS rollout solar array. The first 2 bolts to be released were restraint bolts. He also manually repositioned 2 rollers to get them out of the way, setting the stage for the release of another pair of bolts for the outer deployment restraints, all part of the mechanisms holding the array in its folded position prior to the time that it is manually transported by Cassada over to the starboard fore truss for the electrical hookup and installation alongside the legacy or original array that powers the 3A power channel of the International Space Station.
Okay, we copy. We're going to bring you a body down 20 centimeters, and with the night pass, clearances are tough, so we'll take your clearances from the boot plate and your body.
Sounds good. I've got clear space between me and iROSA. I can maintain this clearance.
Copy. Starting motion, body down.
Copy. I see good motion. Continue.
And to go.
And ramp out motion there. Stop motion.
Okay, there is your 20 centimeters.
What? I guessed it right?
Nailed it.
Okay. All right. Beck, I'm at R3 and ready for settings.
Josh, the settings...
GCA complete, sorry.
Copy. GCA complete.
Okay, Josh, your settings are alpha 3, clockwise 3.
All right, this is the weird one. Alpha 3 is set. Clockwise 3 is set.
That's a good setting.
Half turn on Charlie 1. And on Charlie 2.
And you
245-ish. Is that right?
That's affirmative. So you might want to reset your PGT counter to help out. You're on R3. You've got good settings. Good luck.
Got it. Starting turns clockwise.
Not only did you nail that GCA, but it was a metric. Well done.
Hey Frank, we've got some choppy comm. You were cut out on your last.
It's okay. It was for Josh.
Hey Frank, when you get into a stable position before you work on Charlie 2, we want you to try to readjust your cuff checklist so that it doesn't push your gauntlet down. Yeah, so we can see in the WVS, you want to get that band back up as high as you can on your arm. We want the gauntlet to be able to cover that wrist ring. And we've got a handover.
Yeah.
And Frank, Josh, we're back with you after the handover.
Copy that. Hey, Nick, I adjusted it as best I could. Unfortunately, it's not completely covered. With a glove hand, I can't really move that elastic loop. Every time I move one end, the other end goes back to the starting point.
Yeah, understand. Don't know if there's a way to wiggle that cuff checklist band up towards your elbow as much as you can, as long as it's still accessible for you. It doesn't need to be down toward the wrist ring.
Yeah, unfortunately, that's what I'm having trouble doing. I just can't push it up. It won't expand enough to.
Copy, Frank. So we're going to have you continue to work on the Charlie 2. There's going to be a time in the timeline where Josh is going to be close to you. He might be able to lend a hand to fix that.
Okay. I'm ready for settings for Charlie 2.
Charlie 2 is Bravo 3, counter 2.
I have Bravo 3, counter 2, and I understand 27 turns.
That's affirmative, 27 turns.
$245 on Rubio 3.
You win.
And
R4 counterclockwise?
That's affirmative, and we've got the copy your 245 turns on R3. R4 is Alpha 3, counter 3.
Alpha 3, counter 3 is set, and I'm sorry, from this spot I cannot see the turkey timer. Not
That's
on either side.
No worries. We'll have Frank confirm in a little bit.
Sounds good.
Cassada and Rubio continue work to undo a number of bolts holding the ISS rollout solar array in place on the flight support equipment on the truss of the station prior to its movement by Cassada over to the starboard foretruss for its installation and electrical connection to the original solar array system, the electrical system, the integrated electronics assembly on the starboard foretruss for the 3A power channel. Rubio in the process of releasing a couple of outer deployment restraint bolts on the ISS rollout solar array. The crew continues to operate several minutes ahead of the timeline.
Hey, Frank, before you head back over to the crew lock bag, we'd like you to translate over to stanchion Alpha to see if you can put eyes on the turkey timers at the bottom of those root beams.
Okay, no problem.
The turkey timers referenced by spacecraft communicator Nick Hague are basically status indicators to ensure that the bolts that are being released are fully released. Just a status double-checking device to ensure that the ISS rollout solar array is ready to be released and removed from its flight support equipment.
Yeah, copy, Frank. You see it good. We don't have it on the video. It's a little bit higher up. You'd have to translate higher up on the stanchion. And we don't need the video. But if you want to wait until Josh drives the R4 bolt all the way out, we'd appreciate it.
And just verify that the bearing hole being past the bottom is that full deployment.
If it breaks the surface, if you see it sticking out at all, it's good.
Okay. Yep, it's sticking out like between a quarter and half an inch.
Thanks for the data.
I'm going to translate to the other side. I should be able to see it from the bag. Yeah.
Okay, sounds like a plan.
And I see it protruding from this side also, same distance, 1/4 to half an inch, good bearing hole visible.
That is 245 turns on this side. You can let Miranda know that when I wake up during the night with a recurring dream of counting to 245, I'm giving her a call.
Yeah, copy all, Josh. And copy, Frank, you saw a good turkey timer. You're going to want to retrieve the square scoop out of crew lock bag T.
I knew that. I want to make sure you were paying attention.
Wasn't going to let you go too far.
Okay. I am complete here at R4. Is it Robo next for us?
Yeah, so next step we...
Confirm, I have a maneuver to the carrier back off position when you're ready.
And guys, we want to stand by and hold position right here. We want to try to troubleshoot the gauntlet or the cuff checklist and his gauntlet on the left hand of Frank. You guys are in a close position here. And so once Frank gets the scoop, if he can translate over and extend his arm towards Josh, what we need to accomplish is clear the cuff checklist band off high enough up so that the gauntlet can cover the wrist ring.
Copy. Actually, I think that's going to be hard from this position. I don't know where a safe spot is for you to be, Frank.
Yeah, I'm going to have to just reach out my arm too and see if you can get it.
Well, we got to stay clear of the solar array.
Right. Yeah. Can you reach? No, I don't think so.
I would have the GCA if that's what you want. Nick?
Stand by, we're talking about it just a second. Yeah, Josh, we're good with you GCAing so that you guys can close the gap between you to look at that. And we want to make sure, Josh, that you don't have the same issue. We want to make sure that we can keep the gauntlets over the wrist rings. That's the priority.
We will take care of it. We'll get each other set up here. Duke, if you are ready, I'm going to need a GCA to my right and end up being about a meter. Maybe I can pull it up short of that.
1 hour, 50 minutes into the spacewalk. The crew running about 15, 20 minutes ahead of the timeline, doing very well as they are backing out a number of bolts holding the ISS rollout solar array in place on flight support equipment on the truss of the station. Frank Rubio will soon be breaking torque on a number of additional bolts holding iROSA in place. This rollout solar array will be transported to the starboard foretruss to the integrated electronics assembly to be installed on a mounting bracket and electrically connected to join forces with the original solar array for the 3A power channel on the starboard foretruss.
Continue.
Copy. You have 50 centimeters to go.
Okay, continue. And ramp out in 3, 2, 1, stop motion.
Okay, motion stopped.
Like a Michelangelo painting.
Cassada now helping to adjust the cuff checklist on the left arm of Frank Rubio.
Let me hold on to your mini workstation. Can I work with both hands?
Great. Spin it around here and then pull it. See how I'm doing?
Yep. Yeah, you do. Yep. You can grab both ends and kind of pull out.
I'm trying.
Yeah. Right.
Oh, man. Hold on.
The International Space Station flying directly over Singapore at an altitude of 260 statute miles, moving from northwest to southeast.
The part in your left hand, have the strap there.
Sure, yeah.
Yep. Right by your thumb. Down a little bit. There we go. That was the part that was caught. Yep. I think you got it. Perfect.
All right. You are good. And let's try to get that pulled as far back as we can. Yeah, hold on there. Hold on to that mini workstation. All right, let me know when you're holding.
Ready?
Good. Oh, GCA complete. Sorry, dude.
GCA complete.
Okay. You probably have a good view of that in my heck at least.
Yeah. Hey, Josh, we see it in your camera. It looks good.
All right. Now, can you do something similar to me?
Yep.
Let's see. You unlock. I'll hold you right here.
Got it?
Okay. Yep. And you are clear of that solar array. I'll keep you clear. Just watch your right hand on that panel, and I'll try to keep you stable.
So after a minor wardrobe adjustment for Frank Rubio, the two spacewalkers continue on in this 256th spacewalk in support of space station assembly maintenance and upgrades.
I'll tell you what, if I pull this side, can you do that side?
That's the problem.
We'll just need to be...
If I can...
I don't think there's a way we can affect their locks, but let's be careful.
Yep. Okay.
It's not. It's the bottom part here. I'm going to spin it. So, you see down here, I'm going to turn my hand this way. Right. Almost there.
And guys, we see you working with it. Just watch any of the sharps that are on the cuff checklist. The coil binding can snag on things.
Copy.
All right, Nick, how much more time do you want to devote to this? Is this worth it?
It's also a ton of energy. It's just, unfortunately, the strap is like maxed out.
Yep, copy, guys. Appreciate the effort on that. It looks like the gauntlet's able to cover it up, so we're good to press.
I agree. Yep, and I'll be sure because I can pull mine back. So I think we're good. Good. Appreciate the attention there. All right. I'll leave it to Nick and M1 to figure out where we go from here on Robo.
So I have a maneuver to the carrier back-off position. That's going to bring your body out about 1.5 meters, and then we can take out the Y during that flight.
I'm good for that, and that is not a GCA, so you have the comment if you need it, Rick. Okay, copy. Thank you.
Okay, we're bringing your body out.
Copy.
Starting motion.
Rick, I'm heading over to Charlie 1 to release and put on the A-scoop.
Yep, those are good words, Frank. Syncing back up. We've got Charlie 1 full release to do over there, and then we'll get you in position for Charlie 2 to do the final release.
Okay, copy that. I see good motion.
Frank Rubio will be pressing ahead here to release the final pair of bolts holding the iROSA on the flight support equipment on the truss of the International Space Station. We are approaching the 2-hour mark in today's spacewalk. The two crew members outside, Josh Cassada and Frank Rubio, began their spacewalk at 6:16 a.m. Central Time. They're running about 15 to 20 minutes ahead in the timeline.
Back-off position. We are setting up for a 3-minute retrieval intermediate joint OCAS.
EV1 is go.
Nick, I'm set up for Charlie 1.
Okay, Frank, your settings are going to be Bravo 3, counter 3.
Bravo 3, counterclockwise 3.
Yep, 51 to 54 turns, and the bolt should spring out when released.
51 to 54. North.
EV1, we're ready for the joint OCAS. This is going to pitch you forward 90 degrees and bring you in front of iROSA.
1 copies and ready.
3, 2, 1, starting motion.
See good motion. Nick, how are you feeling about the timeline for removal from the FSE?
Hey, Josh, you read our minds. We were talking about down here. We're on timeline. Consumables are looking great. Looks like we're going to be go for release.
That's awesome news. You guys have put together such an incredible plan. I thought it might be something in the cuff checklist that would give us trouble, not the cuff checklist itself.
At the 2-hour mark in today's spacewalk, flight controllers here, very comfortable with where the two spacewalkers are in the release of all the bolts. and have given the crew a go to release the iROSA from its flight support equipment.
Okay, that's the completion of that joint OCAS. We are setting up for another 3-minute retrieval lineup joint OCAS.
EV1's ready.
Okay, EV1, we are set up. This is going to pitch you forward and bring you up over iROSA.
Copy.
3, 2, 1, starting motion.
Keep in motion.
Hey, Nick. What's about Charlie 1?
Hey, Frank. We're with you.
So about 54 turns. The bolt is really loose, but I guess when you say it pops out, I physically be able to push it back in?
And Frank, that's affirmative. You should be able to push it back in. So if you want to add more turns, you can go beyond 54.
Okay. Yeah, it's super wobbly side to side, but I don't seem to be able to push it back in AML.
And Frank, we're happy with that bolt. It looks like it's released.
Okay, copy.
And Frank, after you stow that PGT, you're going to install the square scoop on the micro square near Charlie 1.
Copy.
Okay, that's the end of the joint OCAS. We have a GCA to publish iROSA retrieval on your go.
Okay, I copy that. Did you expect me to be yawed right, body right a little bit? I'm not quite lined up.
Checking.
Frank, when you have a second, I'll probably have you give a look at the APFR, make sure that nothing changed there.
Sure, will do.
And EV1, your yaw is 0 and should remain that as you come into iROSA. When we bring you in, it's just body in. Everything else should be set up.
All right, Nick, I have that scoop on Charlie 1. It is in lock position, 45-degree angle towards the bottom iROSA.
Copy, Frank. Can we get a quick glove and hap check?
All right. Can I steal the comm after your hap check?
Yes, and I have good gloves, good hat, EV2.
Copy, good gloves, good hat.
Frank, I'm going to steal the comm. The GCA to publish, if you could give a look at maybe why I've yawed just slightly to the right. And M1 EV1 is ready for a GCA to publish for the retrieval position.
Copy, stand by.
Josh, it does look like your footplate is yawed slightly towards your...
And it's the plate, it's not... Actually.
Oh, correction, you're right.
That was just me.
Okay. That looks better.
The plate looks good?
Yeah.
Yeah. All right, dude, ready GCA, no need for yaw.
I'm going to retrieve the other scoop for Charlie 2.
Affirmative, and you're going to get the square scoop with the long duration tie-down tether on it.
Copy.
Okay, we're ready for the GCA to publish. This is going to bring you body in 80 centimeters, and we still have challenging views with the cameras, so if you can help us out.
Copy, and I'll keep you clear.
Starting motion.
I see good motion.
Twenty centimeters.
Copy.
Ramping out.
Okay, I'm going to need 15 centimeters body in, and the sun is coming out, and I have clearance myself.
Copy, 15 centimeters body in. Starting motion.
I see good motion.
Ramping out.
Two hours, 9 minutes into the spacewalk. At the top of your screen, Josh Cassada, his feet planted at the end of the Canadarm2 robotic arm, ready to remove the ISS rollout solar array from its flight support equipment. After Frank Rubio drives two final bolts that are holding the array in its place, Cassada then will bring the array over to the starboard 4 truss work site to begin work with Rubio to install it at the appropriate position adjacent to the original solar array on the starboard 4 truss that governs the electrical output for the 3A power channel.
Okay, that's your additional 5 centimeters body in.
Didn't really see it, Duke. 5 more centimeters body in, and that'll be it.
Copy, coming 5 centimeters body in, starting motion. Okay, that's an additional 5 centimeters body in.
I didn't call it because I didn't see it. We will call that good. GCA complete. Richie, you are a smooth operator.
Okay, that's GCA complete. You have go for iROSA retrieval.
V1 copies. I've got a ret on the scoop here on the right. It is from my mini workstation on the right side.
Copy that, and we see that. So I've got a lot of checks that we can start rolling through.
Okay. It's the first time my hands have gotten a little chilly. I've never used the glove heaters before. If you've got any advice on it, I'll take it, but I might have to turn them on for this next maneuver. In fact, they are on now, and I'll let you know if I need to turn them off before we go.
Copy that. And just for your essay, you should be in the sun for most of that relocate.
Okay. Sounds good. Yeah, it wasn't. They weren't cold earlier. Frank, you can have the comm if you need it.
Okay, I am positioned at Charlie 2.
Yep. And Frank, we're going to hold right here because we're going to go run through all these buddy checks because as soon as we release that, it's going to be free from the FSE. And we've got a great view on your HECA. Just lots of delicate stuff below where you're trying to drive that, so just a heads up.
Yep, copy.
Okay, so let's do glove and hap checks.
The sun's not in a great spot for me on this one, but no deltas to the gloves for EV1.
No deltas for EV2.
Copy.
Half is dry for EV1.
Half for EV2.
Okay, and so let's, Josh, you want to make sure your tools and tethers are clear.
Back me up on that if you would, Frank. This eye looks great, and I see you rutted to the square scoop. And the side of the footplate that I can see looks good. You look clear. Sounds good. So we are clear.
Copy. So then visors, glove heaters, cooling, just like we said, you're going to be in the sun for most of this translation.
Any risk of my hands getting too hot with the gloves on, glove heaters on?
Affirm, that's a risk.
Not do that. Okay, so glove heaters are going to come off.
Copy.
Visor, let's open them now, do water checks, and then visors will come back down. If you bring your visor up so I can see if you've got water.
2 hours, 13 minutes in. Josh Cassada about to pull the ISS rollout solar array away from the flight support equipment to move it toward the starboard forward truss work site for its installation.
Josh, you want to make sure that your heels are secure.
Give me one more check on that. They feel secure to me. The left one was the one I think you were looking at earlier. Looks secure for me. Okay. Heels are secure, Nick.
Okay, one last check. Gauntlets.
I am closed on left and right. And for EV2.
Okay, and so Josh, you're going to maintain control of the iROSA in the FSC. Frank, you're going to release the bolt and then install the scoop with that long duration tie-down tether on it. Josh, when you're ready, you're going to give the go to Frank. Frank, your settings are Bravo 3, counter 3.
Bravo 3, counter 3.
And stand by for 1 second after you're set.
And Frank, those are good settings.
Frank Rubio about to release the final 2 bolts holding the array in place on the flight support equipment. Cassada ready to pull that array out of the FSE to begin movement over to the starboard forward truss work site.
Bravo 3, counter 3 set.
We'll be back momentarily with our video capability from the International Space Station, just now passing between satellites on the tracking and data relay satellite system.
Release it, I'm going to have to push it away from me. Once you get it on there, if you can confirm that, I just want to plan ahead.
Sure.
That will it's going to be a little harder to get off when we get over there to the mod kit. Okay. With that, you've got my go for sure.
And guys, we're 10 seconds from a 20-second handover.
Verify I have a go to release E2.
You have a go.
Okay.
All right, let's do it, Frank. Wow, it's really going. Oh,
Okay. 20.
It's better. Get it on there quick. This one's really trying to get away.
Okay. Wait, when?
Watch that upper iROSA.
The wheels on this arm are interfering with the insertion.
The upper arm?
Yep.
Or our arm? Well, don't. It's trying to get away here, Frank.
Okay. Hold on, I gotta put it on lock. All right. You ready for me to go to lock?
Yeah, go to lock. Forging. All right,
Okay.
push it away.
To lock.
Okay. Can you get my ret and put it on the scoop so I don't have to let go? Or tell you what, I'm gonna. Yep.
I have it. I have it towards you.
All right, I got the scoop. All right, I got both scoops. If you can get my ret and put it on the long duration tie down tether, we're good. It's maybe a bit of a reach for you.
Yeah, unfortunately, but I can hold the scoop.
Okay, why don't you hold it in the FSC?
I have the scoop.
Okay, you got the scoop and you're pushing Zenith? Pushing Zenith?
Towards you.
Towards me. That's good. All right, stand by. All right, and am I close?
Okay, let's
Tell me which way to go.
let me have the ret.
Okay.
Okay, you take the scoop.
I'm back to the scoop.
2 hours, 19 minutes into the spacewalk. Rubio and Cassada working in tandem
I gotta release my ret.
Go for it.
as they begin to move the ISS rollout solar array away from the flight support equipment, upon which it was launched in the trunk of the SpaceX cargo Dragon.
Okay.
You can see behind the array that Cassada is about to move to the starboard truss, the second of the two ISS rollout solar arrays that these two spacewalkers will install on the other side of the backbone of the station onto the port truss on December 19th.
And then I'll have to just go down towards the bottom of my iROSA when I
Oh,
get
perfect. That's great.
Good.
Towards the bottom. I'm sorry, towards my head.
Yes, correct.
Oh,
Yep.
okay.
Sorry.
Got it.
Upside down here.
Hey, Nick, we got it. It's on there. It was pushing pretty hard to get off, and now it no longer is. So we are we're in a good config and stable.
Copy all, Josh. Good news. Nice work together on that one. And so got a caution here not to release the iROSA, or prior to releasing the iROSA, make sure the FSC is not moving. So when Frank gets into a good position, you'll be able to slide the iROSA nadir to release it from the pins.
I'm en route towards, okay.
Sounds good. And Duke, you understand that Frank is making his way to Delta for watching?
Duke, you with us? I heard you, Josh.
Okay, sounds good.
Okay, so Frank, I see you in a decent position. And so if you're good with it, and then Josh, you're able to slide the iROSA nadir, and that should slide off of those pins that are on the FSC, then you'll have it.
Copy that. We're going to get a hold of Duke here first.
Okay, we are standing by and ready for the maneuver to publish iROSA removal on your go.
All right, stand by. We're going to release from FSC first. And if everybody's go, Frank, are you go? You're go. All right. So we're going to go nadir slightly, and you can help guide that if you want.
Hey, that's good. Depends.
Okay. All right. Now pull. There we go. Okay.
And the ISS rollout solar array, the third in the series of upgraded augmenting arrays for the station, is free from its flight support structure.
All right, Frank. You've got the comm for the Robo.
Okay. And Duke, you have a go for GCA to published iROSA removal.
Okay, this is going to bring EV1 body down 4 meters.
Copy.
Starting motion.
I should have about 3 inches of clearance from the grapple fixture.
Copy.
I see motion. Good motion. Clear the grapple fixture in about 10 inches.
Okay. Are you putting any force into iROSA?
Oh yeah, I'm trying to just keep it slightly away from. Still have about 2 inches of clearance.
Okay.
Okay, you are clear of grapple fixture. Continue.
Copy.
How's it feel?
Somehow heavy and light at the same time.
Okay, you are completely clear from this side, so
Copy.
safe travels.
Thank you.
All right, Nick, I'm going to
1/2 meters to go.
Copy.
Say it again. How many meters?
2.5 meters to go.
Copy.
Smooth as glass, Josh Cassada
And Frank,
moves with the ISS rollout solar array away from the flight support equipment on the truss of the station.
And Frank, big picture here, you're going to put that 12-inch on the socket caddy. The socket caddy is going to end up in the crew lock bag, and then you're going to install your 2-inch from your trash bag.
We have 1 meter to go.
Copy.
Ramping out motion.
Copy.
Okay, that is our published position. We are setting up for the 2.5 minute iROSA pitch joint OCAS.
Copy.
A good view of Josh Cassada with the ISS rollout solar array. On Earth, it has a mass of about 750 pounds. Once unfurled, it will measure 60 feet long by 20 feet wide, attached to the integrated electronics assembly alongside the original solar array on the starboard fore truss, producing power for the 3A power channel.
All right, Nick, I have a good socket swap with a 2-inch on my PGT, good pull test, and a 12-inch back on the caddy, good pull test. Do you want me to leave the rep that's holding it outside, on the outside of the bag or the inside of the bag?
And that's copy, good socket swap, Frank. What we want you to do is put everything inside that bag. We're cleaning it up, and if you want to close it up with everything inside, turn the doors facing the tower and cinch down the straps. That's how we'll leave it as you move out.
Okay. Can I leave the wire side that was holding the PGT on the outside?
That's affirmative.
Okay.
Okay, EV1, we are set up for the joint OCAS. This is going to pitch you up and bring you in front of the FSE.
Okay, I copied. Just a heads up, I'm having can't get a whole lot of pitch on it, so we'll take the 3, 2, 1. That'll be super helpful.
Okay, are you ready?
Understand pitching on my back. Pitching up.
Okay, for pitching up.
EV1 is ready.
3, 2, 1, starting motion.
Hey, Nick, everything is inside the bag, and the bag is clean.
Copy.
Yep, copy that, Frank. You've got the doors closed. We'd like the doors facing the tower, and if you can cinch those straps as best you can that are holding it in place, that's perfect. Ground's happy, Frank.
Okay, great. Okay, and verify from here I go to the left side of the market.
Yep, Frank, the next step is going to grab, you're going to relocate Josh's red hook.
Copy, thank you.
And Frank, that's out there on the cedar rail, mile marker 6300.
Ocean's ramping out.
Copy that.
3, 2, 1.
All right, I've got the hang of it now.
Nicely done. We are in pause hold.
And you guys are smooth. Copy.
You know, that's Koichi. All right, we're setting up for a 3-minute outboard joint OCAS.
I understand. Outboard. ED1 is ready. Frank, let me get a picture of you.
I don't even know where you are now.
It's okay.
ED1, we are set. This is going to bring you body left and body down a little bit.
Okay, body left, body down. ED1 is ready.
3, 2, 1, starting motion.
I see good motion. Oh, this one's faster. Wow, a lot faster. Okay.
Flying toward the west coast of South America, Josh Cassada holding the ISS rollout solar array, being maneuvered toward the starboard 4 truss worksite for its installation to augment power capability for the 3A power channel on the International Space Station. We are 2 hours 34 minutes into the spacewalk, everything going very smoothly, the crew running ahead of the timeline for the day.
Okay, Nick, I have Josh's red hook on my red reel. Reel is unmarked, and his hook is unmarked.
Okay, Frank, we copy that. Check your gauntlets down, and then you're heading out to the S4 IEA, and you're going to be stowing the red hook near the radiator.
Okay. And gauntlets are down.
Okay, we are ramping out.
Copy.
Okay, that's pause hold, and we are setting up for the next, it'll be a 3-minute IEA lineup FOR OCAS.
I'll take it.
EV1, we are set. This will bring you body in and up under the IEA.
EV1 copies, and I'm ready.
3, 2, 1, starting motion.
Of course, I see good motion.
And Frank, Nick, back with you. Got a caution here about the red hook location is going to be near an IEA radiator, so just be aware of that. The handrail you're looking for is 2217.
On there.
You are clear of the iROSA, but I don't think you realize how close we are. We're only 3 feet away from each other when you swing.
Oh, really?
Yeah.
Thank you for letting me know.
Oh, no problem. It's not an issue. It does look just like that.
Ramping out motion.
Copy.
Next, so the red hook, Josh's red hook, is on 2217, the inboard expansion.
Yeah, copy, Frank, 2217, you got that down. Just on the edge of our view here, it looks like you might be crossed back at the, just right where the Sarge is at. Just wanted to have you double check those safety tethers.
Yes, it looks like it went under. I'll fix it real quick.
Copy, thanks.
Okay, we are pause hold and setting up for the GCA to publish iROSA install.
Okay. I think we can do that without Frank in position. Do you agree? The published position? I've got good clearance. I can see on this side of the iROSA, so station Zenith, I can see just fine.
A copy, and we have good views as well. We're setting up.
And Josh, we chatted over it. If you got good clearance, we're good to press with the GCA for the published install.
I've certainly got good clearance from right and forward, and from my chin up, from my chest up.
And I'm in a good phase here, interrupt.
Okay, copy that, Frank, and you're going to head out into the left side of the mounting bracket.
Do you need the comm anymore, Frank?
Negative.
Okay, EV1 is ready GCA to published install position. I'll let you know if I lose clearance.
Okay, we copy and we're setting up.
You okay with this, Frank?
Yeah, I'm 30 seconds away.
Sounds good. I can see you translating. No rush, dude, but we are ready, GCA.
Hey guys, I've got some cautions and warnings I'm going to read up real quick while Frank gets into final position. So don't put your fingers in the iROSA pin slots on the inside or an outside of the root beam structure, and then when on the aft side of the mod kit, avoid contacting the legacy blanket boxes and protruding trunnions. Also, you're going to want to, when on the mod kit, not impart loads simultaneously. That's translation, unfolding, bolt tops, connectors. So don't move simultaneously. Sudden stops and quick grabs are not allowed on the mod kit, so translate slow, and 30 pounds max lateral force on the mod kit during and after iROSA soft capture.
E1 copy.
E2 copies.
Okay, EV1, we are all set up. This is going to bring you a body left to about 2.5 meters.
Okay, and I'm going to turn the GCA over to Frank. So EV2, you've got the GCA.
Okay, copy that. And just verify you said this is GCA to publish, correct?
Confirm this is a GCA to publish, bring EV1 body left.
Okay, you are clear.
Starting motion.
Two hours, 43 minutes into today's spacewalk. Josh Cassada and Frank Rubio about to begin work to install the ISS rollout solar array onto its mounting bracket on the starboard forward truss of the International Space Station. Cassada wearing the suit with the red stripes along the legs, holding the iROSA, as it is called by its acronym. Again, these are 750 pounds apiece in mass. Once unfurled after their installation, will be 60 feet long and 20 feet wide to augment the electrical capability of the 3A power channel of the International Space Station. This is the third in a series of at least 6 iROSAs to be installed on the International Space Station.
We are ramping out motion.
Copy.
Okay, Frank, that is the published position.
Great, that's a great position.
Frank, I think we're going to need a little bit more body left for me, so in closer to you to plug in.
Okay.
Just because I'll be at the far end.
Yep, so the scoop bottom only has about 3 inches clearance to the bracket. Do you want to remove that first?
I see it. Why don't we do it this way? We'll move this way, GCA, and then take off the scoop. Careful, careful, careful. Let's see. Give me 1 second. Let's just impart the forces here. All right.
Okay,
Yeah.
let's go GCA, 10 centimeters, body left, towards the mass canister.
Copy, 10 centimeters, body left towards the mass canister. Starting motion.
See motion, good motion. About in 3, 2, 1. All right, Josh, unfortunately your press only has about an inch of clearance.
Yep, I'm watching it. I can see my shoulder. We're good here. Just watch your helmet on the bottom there,
Okay.
so we don't push it away.
Yep.
Do you want to go co-linear with the strut there? You put your feet wherever you want.
Yeah.
I'll turn it over to you, and I'll put the one handrail there, and then I'll take off the scoop.
Okay. I've got this hand here.
Okay, let us know if you're done with the GCA.
We are GCA complete.
Copy, GCA complete.
Are you good with our plan? He's got a hand on it. I'm going to take off the scoop in my left hand, and do my best to put it on the mini workstation.
And brakes are on. Go for iROSA install.
Copy.
Thank you, Duke.
And Josh, that sounds like a good plan.
All right, Frank, I'm going to take my left hand off.
I've got this end.
You probably want to just not, if you can, not put any forces in because it doesn't take much.
Okay. You are going to have to put a fair amount of force on that lever, so.
Got it. That's unfortunate. I'm going to go through.
Yeah, through capture and all the way to release.
Yeah. I don't feel very comfortable seeing a loose end.
It looks like you're past capture. Looks like you might be in relief. It's hard to tell from there. You don't get too good.
Trying not to touch. I'm not going to put this in my mini workstation.
Nope, just let it float. Should be clear. Okay, let's go bring it towards me to align laterally first. Let's say about 20 centimeters.
Translate towards you.
Correct. Continue.
Watch your hand. I'm going to do the pitch. Let's see, my roll for our frame reference.
Okay.
I'm going to roll it your end towards you.
Cassada and Rubio in the process of installing the iROSA on a mounting bracket on the starboard fore truss. There'll be two soft capture features properly engaged when the iROSA itself is correctly aligned on the mounting bracket.
We are on the platform and aligned. We just got to bring it towards the soft capture features.
All right,
straight back.
We'll stick it in the holes first and then go to the soft capture, yeah?
Okay, yep, ready?
Yep.
Continue. Push, in, continue.
More?
Yep.
Okay. That's it for going towards the...
No, bring it maybe a centimeter towards me.
Translate.
Yep.
Okay.
And now keep pushing towards the mass canister. Give it about. You seem to want to go. I need to probably check the soft capture features.
I can see they're the same, and they are cocked and locked.
Okay.
Like they have not triggered.
Okay, we're aligned. I see the tabs are almost perfectly centered.
So maybe manually release a soft capture? That just feels like we're in the slot.
No, we're not in the slot. We're aligned, but we need to bring it back towards the mass canister. About 2 inches. There we go.
Something's blocking it. All right, Frank, let's slow down just for 1 second. I can't go any closer to the mod kit. I'm taking my right hand and pushing.
Yep.
So there's something blocking it.
Okay.
And when you pull yours, we yaw.
Okay, let me check. Do you have it? I need to let go a moment.
Yeah, don't push it.
Nope. Got it. Yeah, I don't see the soft capture features, so they should not be the ones blocking it.
Right. So you can see the slots. You
Yep.
see the teeth that go in them.
Yeah, and there's nothing.
Okay.
Well, now we're come back towards me another 3 inches. And now once again, we're aligned. We are flat against the platform.
We're not flat right now.
Yeah,
So that's okay.
Just came up. Okay, we're aligned. All right, can we go straight aft?
Towards the runway?
Towards the mast canister, yep.
Okay. Well, something's keeping us from going.
Okay, both of the tabs are slightly in there.
Is it an angle thing where we're not flat enough?
My side looks perfectly flat on the platform. How's yours?
It is flat and flush.
Yeah.
Hold on for 1 second. Get away from me. Hey, Nick, I got a question about the mod kit.
Thank you, ma'am.
Good for you there.
Yeah, I got you, Josh.
I'll have you loud and clear.
All right, so on the mod kit, there's an arrow that I think is the very center of the mod kit. It's a label, and there's a left label and a right label. Can you confirm that the hinge will be lined up with that arrow?
Checking.
If that's the case, Frank, we're going to need to translate your way about a ½ inch. I don't know how that makes sense with your plot.
Well, right now, that would make sense, actually. We translated back towards you a little bit.
Okay, so let's go a little bit towards you.
Okay. Continue about, okay, right there.
Okay, so that arrow is not at the hinge. Hinge is going to be about 1 inch my direction from that arrow.
Okay.
I would have thought that the hinge would have lined up right with that midpoint.
Yeah, Josh, that arrow should line up dead center with the hinge.
Okay, Nick, then I'm sure you can't see very well my Heka. The problem is, Frank's got the slot aligned, but that arrow is not where the hinge is going to be. That arrow is about, right now, a ½ inch towards him, meaning the hinge will be a ½ inch mod kit right from the arrow. If we were able to open it.
Yeah, copy, Josh, and we can see it in the WVS. We're talking about it.
Okay.
So I got to let go real quick just to realign my body.
Got it.
Got it.
Just watch you don't hit the iROSA if you can.
Yep, thank you.
Yep.
So right now our yaw is off a little bit. The tabs are aligned, but my tab is no longer.
Watch your hand. Yeah, we're pitching down. Okay. Thanks. All right. So you got to go your way and a yaw, you said?
Yeah, give me a second. I'm losing my position here.
And Frank, Josh, our recommendation here is, Frank, if you could cycle the soft dock, the T-handles, just to let them extend and then reset them.
Okay. Josh, you have the iROSA?
Stand by for 1 second.
Okay, I have it.
Do you think that's really what's happening? Because I can see the soft dock, or the soft capture features just barely sticking out of the surface. But I can see that they're both in the J-hooks. I don't know that those are keeping it from installing.
Yeah, copy that.
I'm pretty sure it's not. But
yeah, we want to make sure they're just not cold stuck in the open position.
oh, I see. Okay. I have the iROSA. Watch your helmet on the iROSA.
Okay, thank you. these.
Yeah, and Frank, what we'd like you to do is have them full deploy, if you can fully extend them so that they would be in the deployed position, and then reset them for the capture.
Okay. I don't know if you see that, but it just takes a lot of force. There's a lot of stiction.
Watch your helmet.
Yep, we're watching in the HECA.
Thank you. They are cycled several times, and they are in the J position.
So, Nick, if I understand, have Frank get these in the slots and then manually release the soft captures, correct?
Yeah, if you've got it lined up and they're not extending, that's an option to manually release them.
We try that, Nick? Or, Frank, should we do that?
Sure.
I'll do my best to hold it in spot.
Let me see if I can get you aligned, and then...
Okay. Looks like it's going to need to translate your way at least an inch. And then roll your end towards you.
Yep. Come towards me, maybe 2 inches.
Okay. But ladies.
Approaching the 3-hour mark in the spacewalk, Josh Cassada, Frank Rubio are fine-tuning the alignment of the ISS rollout solar array onto its mounting bracket on the starboard foretruss.
Okay, we are flat, we're aligned.
Okay. If you want, I'll hold it there and you get one of those J-hooks in.
But we're not in yet. We have to slide it in maybe 1.5 inches. I mean, so we're aligned. Just got to go aft.
But we can't see what's keeping us from going
Yeah. If you can hold this,
Yep.
I'll go down and I can actually push on the beam also. Can you hold it here?
I can.
Okay, you got it.
Be real careful not to bump it.
Yep. And I can see our yaw is off from this angle.
Unfortunately, the sun is right in my eyes and I can't maintain the angles.
And Frank, Josh, just looking at your helmet cam, it looks like one of the soft dock captures did go down. I don't know if it's engaged or if you're going to need to reset it.
It is not engaged.
Did it reset?
Okay.
I can actually kind of line us up from this end because bolt holes are right there.
That's great. I guess we got to figure out what's keeping us from getting inserted.
All right, so right there we should be lined up. I'm going to pull the soft captures down. I have a third hand right now.
That's good.
Yep, that's what it was.
I can't wait to hear that lesson learned at the debrief.
Okay.
That's one. What's your helmet?
Okay, that's two.
Well, you said he did it. We got 2 installed.
Holy cow.
No kidding. There's a huge sigh down here. Well done.
That's not the way it was supposed to be, but it worked. All right, nice job, Josh. I know you've been muscling through that.
No, it's okay. I'm just trying to blink the sweat out of my eyes.
Yeah.
At the 3-hour mark, the iROSA is now engaged and mounted on the mounting bracket on the modification kit on the starboard foretruss. A little elbow grease required, but nonetheless, iROSA is on its mounting bracket on the S4 truss.
A couple second breather here after struggling with that. That's more than cool.
Oh, the sun's setting.
I did too. Yep, that sun setting is going to help. All right, my ret is off. We are saying we're installed because we've got 2 shaft captures. So the ret is off. The scoop is going to stay on for now, correct, Frank? Or correct, Nick?
That's affirmative.
Okay. Tweety and Duke, we are installed and ready for the back-off maneuver.
Copy, we are setting up for the iROSA backoff.
Feels weird not to be holding onto an iROSA now.
I know. It also feels weird to have the Earth completely above you.
Hey, and guys, big picture. Big picture.
That's upside down.
Yeah, sorry to interrupt, guys. Just big picture, you're well ahead of timeline. You're going to see an eclipse come. This is not the one we're targeting for the cable mate. We're working on the next eclipse after this one. So when it gets dark, we're not behind.
Got it. Thank you.
Awesome. Thanks, man.
Okay, EV1, we are set up. This is going to bring you body right about 2.5 meters.
With the iROSA installed on its mounting bracket, the next step, once Cassada is backed away at the end of the station's robotic arm from the work site to provide clearance, will be the release of final hinge restraint bolts that will enable the iROSA to unfold like a flip phone to its pre-deployment orientation.
Nicely done, Frank. I cannot wait to hear what it was.
It was just the outside soft capture one just wasn't, so I just pulled it all the way down and then it slid right in.
Awesome. I see. It just wasn't sliding past the little nubs.
Soft capture wasn't so soft. Not quite soft enough.
Holy cow.
Ramping out motion.
Meanwhile, the space station is about to fly into an orbital sunset over Cologne, the home of the Columbus Control Center.
And setting up for a 2.5 minute R6 backoff joint OCAS.
EV1 copies.
Hey, Frank, we see you in position, waiting for Josh to get in position through these JOCASs. If you can go over to that third soft capture, the one we're going to use when we unfold it, we'd like you to try to cycle that one as well to see if we can get ahead of the game.
Okay, that'll work.
And 10 seconds to a handover.
Okay, EV1, we are set up for the joint OCAS. This is going to basically body, yaw, you left 90 degrees, and bring you over to face iROSA.
EV1 copies, and I'm ready.
3, 2, 1, starting motion.
I see good motion. Nick, can we start talking about settings for R6?
Yeah, Josh, those settings are going to be Bravo 2 clockwise, I'm sorry, counter clockwise 2. Bravo 2, counter 2.
Bravo 2, counterclockwise 2, copy.
Yep, Josh, and before we drive R6, we're going to daisy chain those scoops together and hand them off to Frank.
That sounds great. All right. Copy that we're going to, well, with the long duration tight on tether, get that other scoop off, and then I've got Bravo to R2 set for R6 when we get there.
Yep, copy all. Those are good words, Josh.
Sure haven't gone very far for a whole lot of trips.
You feel the same thing with that right soft catcher?
No, that one seems to be a lot easier to move.
Oh, well, yep. Great.
Okay, that's the end of the JoeCast. We are set up for a GCA to published R6 approach.
EV1 is ready for a GCA to publish for R6. Or GCA?
Okay, EV1, we are set. This will bring you body in 120 centimeters.
Body in 120 centimeters. EV1 is ready.
Copy. Starting motion.
I see good motion.
Okay, our cameras are degrading. If you can watch your boot plate and your ingress aid.
Got them both.
Centimeters.
Okay, we're clear.
Ramping out.
Concur.
Okay, that is our published position.
That is going to work fine. GCA complete.
Copy. GCA complete. Go for unbolting.
Copy. I've got the other end of the long duration tight end tether on the scoop here, and I'm happy to release.
Yeah, copy, Josh. You've got those on each end of that long duration. You're going to pass it off to Frank.
Sure. You want me to give you a rep?
I'm ready right now to both.
Okay.
I'll pass them both to you, and then we'll do a rep swap.
No problem.
Okay.
I'll just take it. I can solve it.
No problem. There we go. Slowly pass you on.
This is Mission Control Houston, 3 hours 11 minutes into today's spacewalk by Josh Cassada and Frank Rubio.
And Frank, you're just going to temp stow those on the exterior bag ends.
Okay.
The two spacewalkers began the 256th spacewalk in support of space station assembly, maintenance, and upgrades at 6:16 a.m. Central Time, moving out of the Quest airlock after placing their suits on battery power and working extremely efficiently, have removed the ISS rollout solar array, one of two delivered last week on the SpaceX Cargo Dragon resupply craft to the International Space Station, removing it from its flight support equipment. Cassada then transported the array over to the starboard fore truss, where he and Rubio moments ago installed the array on its mounting bracket. The next step will be to begin the process of releasing hinges, basically hinge restraint bolts, that will enable the array to unfold like a flip phone into an unstowed position prior to the time that the array itself would be bolted in place on the integrated electronics assembly, electrically connected to the same electrical system currently powering the legacy array, or the original solar array that was delivered on the Space Shuttle Atlantis on the STS-117 mission in June of 2007 to augment power for the 3A power channel on the International Space Station.
I think we're going to start driving here, R6, Bravo 2, counter 2.
Copy. Go.
There's 19 turns. It just popped out, and actually this one does have a white line.
Copy, and we see the white line as well. So you can stow the PGT, and then you'll work with Duke to go through some maneuvers to get in position for the unfold.
Just make sure I didn't miss anything there, Nick. It's stow the PGT and maneuver, is it?
Yeah, affirmative. It's you're going to go to a R6 back off position and then work for the APFR egress maneuvers.
Great. Sounds good.
Okay, and we have a maneuver to the R6 back off when you're ready.
All right, stand by. All right, EV1 is ready for the R6 back off.
Okay, this will be body out, 120 centimeters.
Copy, body out, 120 centimeters.
Starting motion.
I see good motion.
Fifty centimeters.
Copy.
Ramping out motion.
Copy.
Okay, that's our published position. We are setting up for a 3-minute APFR egress JOCAS.
Okay, stand by. Frank, I'm seeing your safety tether go right over my head. I'm assuming it's not caught in my helmet.
Fortunately, with your light shining right on me, I can't.
It looks like it's going straight and not hung up on me.
Yeah, no, it's going straight, and it was going straight when I came here.
Okay.
Yep.
And do you know if we're moving towards my head or hopefully towards my feet?
Eagle 1 for big picture here. First, we're going to yaw you right 90 degrees, and then we're going to move you body left back towards iROSA, and that's your egress position.
Okay. Just for your essay, I've got Frank's safety tether going right over my head, like I can almost touch it with my hand. Is it a problem just to give me 10 centimeters towards my feet, and then we'll definitely be clear?
Okay, checking. It's a joint OCAS, so I don't think it'll keep you nadir if that's what you're looking for.
I think we got to send this one over to Rubio. I can't say for sure that I'm not going to go right through this safety tether on this joint OCAS.
Hey, Josh, we were chatting about it. In this next maneuver, there's no body up motion. If we do go body down, we'll need to change up some modes, but you shouldn't go body up at all in this next maneuver.
Perfect. Thank you so much, Nick. That Duke, I am a go, and I'll keep an eye on the safety tether as best I can.
Copy, stand by.
Before the bolts are driven to basically free up the hinge restraints on the ISS rollout solar array, Josh Cassada will be placed in a position to leave the articulating portable foot restraint that he's been mounted on at the end of the Canadarm2 robotic arm, which has been driven by Koichi Wakata with the assistance of Nicole Mann from the robotics workstation in the Destiny laboratory of the International Space Station.
See good motion. And I am opening from the safety tether with that motion, so that's great.
Good to hear.
Doing okay, Frank?
Yeah, doing great. How are you?
I'm great. Babysitting at iROSA can be a lonely job.
Amazing how quickly your brain adapts to, like I see myself being right side up, and I'm sure you see yourself being right side up.
Yeah. Join you here shortly.
Well, go slow when you get off, because it'll be a little disorienting.
Yeah, absolutely. Thank you.
Okay, that's the end of the JOCAS. We are setting up for GCA to published APFR egress position.
Copy. And you are a go and ready GCA to the published APFR egress position.
We copy? Okay, EV1, we are set up. This is going to bring you body left 1.5 meters, and we have degraded cameras, so if you can help us with clearance from your body and the APFR to iROSA.
Okay, that's going to be hard because we're moving towards my left shoulder, but I can see right now all of iROSA. We are currently clear.
Okay, if at any point you lose iROSA, let us know and we will pause.
Okay.
Starting motion.
I see good motion. You're clear.
Copy, 1 meter to go.
Copy. Still clear. Clear of iROSA, I cannot see my boot plate or anything below me.
40 centimeters.
Copy. 20 centimeters.
Okay, copy. Body out 20 centimeters.
That's right.
Already moved. And you confirm you have clearance?
In front of me, yes. Behind me, no. I can see you. You're clear.
Okay, we're coming. Body out 20 centimeters. Starting motion.
Copy. See good motion.
10 to go.
Continue. Ramp out. 3, 2, 1. Ramp out.
Okay, we're pause hold.
Okay, and now I'll need 40 centimeters body left, and I have good clearance to the mod kit.
Okay, confirm 40 centimeters body left.
Affirmative. 40 centimeters body left.
Okay.
Three, 2, 1. Ramp out.
Pause hold.
Copy. GCA complete.
Copy. GCA complete. Brakes are on. Go for APFR egress.
Copy. Go for APFR egress.
And Josh, you'll want to just use that Ingress aid only when you're egressing. I know the mounting bracket might be in easy reach, but just use the Ingress aid. And when you're done with it, you want to stow it in a low profile.
Okay, I am egress now, using only the Ingress aid. Now I can touch the mod kit. My understanding is correct?
Affirm. Understand your egress. Do you want to stow the Ingress aid in a low profile?
Understood. Okay. I made a bad decision on that GCA because I'm about to lose the length of an Ingress aid.
This is Mission Control Houston, 3 hours, 26 minutes into the spacewalk by Cassada and Rubio. About 26 minutes ago, the ISS rollout solar array, the first of 2 delivered last week on the SpaceX Cargo Dragon resupply mission to the station, was installed on its mounting bracket on the starboard fore truss. Josh Cassada, who had spent the last couple of hours at the end of the station's robotic arm and a portable foot restraint, first hauling the array over from its flight support equipment to the mounting position on the starboard fore truss, has now exited the foot restraint at the end of the robotic arm, and he will set up shop with Rubio to drive a couple of bolts to release the final hinge restraint that will enable the array to fold open.
Help things out along.
Copy. Disregard. We will not need the GCA.
Copy. No GCA required. Okay, brakes are back on.
Thank you.
Once the array is folded open, then Cassada will be working to drive a series of bolts that will affix the array to the integrated electronics assembly on the International Space Station. Electrical connections will be hooked up. That basically mates the array's electrical system to the original array that sits on the starboard 4, starboard 3 truss that was delivered 15 years ago to the station on the STS-117 mission of the shuttle Atlantis. The two spacewalkers will then monitor the unfolding, basically the unfurling of the array to its full length of 60 feet, following the tensioning of that array to its final configuration.
Obviously, you're just going to want to maintain awareness of your safety tether back to the arm because that's where your anchor's at.
Give me 1 second, and I'm just going to get it in front of my body as opposed to behind.
And Josh, as you're working that, you're going to want to eventually get a fair lead on that lower right structure and lower strut, or lower handrail to help keep your safety tether clear.
Copy that. Sure.
Yeah, we want to put that in after the maneuver.
After the maneuver, okay. With that, my safety tether is clear.
This is the third in the series of at least 6 iROSAs that are being delivered and installed on the International Space Station. The next one, also carried to the station on the SpaceX Cargo Dragon a week ago, is scheduled to be installed on the port 4 truss of the station by Cassada and Rubio on December 19th.
This is going to be ISS port 3 meters and zenith 2.5 meters.
Okay, we copy. And Frank, when they're way clear, let me know, and then I'll flip around, and we'll get to work. Okay.
Each of these iROSAs will produce and are producing more than 20 kilowatts of electricity. Again, designed to augment the existing power supply of the International Space Station for future research and utilization operations.
You should have enough clearance to swing your feet down, body towards your right.
So, now we want. Okay. That's making it hard because it's moving on me.
EV1, we have about 85 centimeters zenith to go, and we're having a hard time seeing the APFR from the truss. Can you help us out?
I cannot. Can you? Give me 1 second. APFR is clear. If you're looking for clearance on the IA, we're clear.
Okay, we're going to continue zenith 85 centimeters.
Copy.
Centimeters to go.
All right, Duke, I'm kind of losing you now because of a light that's kind of directly at my eyes, so I can't quite clear the last 10 centimeters or so.
Okay, we are at the published position and brakes are on. Stand by while we set up some cameras.
And so, Josh, once you get that fair lead in on that lower strut, then you're on the right side to get into position for the unfold. I got a warning that when we do that unfold, it's a pinch point, so keep clear of the hinge on iROSA.
Okay, understood.
Give you 2 copies.
I don't think this fair lead's going to stay, given where they are. So I've got SA on my tether. It's going across the front of my body to the right. Actually, just it's. I'm going to try to get it on my left side. Right, you got me.
Yeah, I got you. Copy.
And Josh, just to let you know the intent of that fair lead, we're just trying to clear your safety tether out of the way of the unfold as that happens. So, using that lower handrail to try to string it down towards your feet was the idea.
Understood.
Yep. Josh, I think for now, if you just leave it on that side, your body will help kind of clear it.
I think so too.
Yep.
So we're just going to go across our body on that one.
Yep.
And I think that will keep it out of the way of the unfold, if you agree.
Yep, I agree.
Yep, and if you guys have awareness of it, you're good.
Okay, EV1, we're set up on our end. Let us know if you need a GCA once you get to the tether swell.
Okay, that's a little bit down the road. I appreciate it. Koichi, that was amazing. Thank you for the ride. I will definitely get on my rideshare app and give you 5 stars when we get back inside.
That's the V of your health, Josh.
Okay, Nick, we are ready for the unfold if you are.
Your go.
Okay. Starting to open. Coming your way.
All right. And the soft capture is armed. Watch those fingers.
Yep.
Here it comes.
Well clear.
Okay. All cables and tethers are clear.
Yep, you're clear on this side. I'll be on with that soft capture. Oh, actually, it's engaged. Nice. No, it's went early. Okay. Let me release it. Okay. Okay, it's released. Okay, now. Now it's captured. Okay. Nice. Very nicely done.
Copy, guys. Great work. That's a good install. It's a great config. While you're in that position, we'd like to get glove, HAP, and gauntlet checks from both of you.
Okay. Gloves for EV1. No noticeable changes. And HAP is dry, and gauntlets are covered.
And EV2, no noticeable changes on my gloves and dry hat. Gauntlets are covered.
Copy. Good checks for both of you.
3 hours, 38 minutes into the spacewalk, the ISS rollout solar array has unfolded.
You're going to work to stow the long-duration tie-down tether with those scoops on it inside of crew lock bag M. And Josh, you're going to translate to work the hinge bolts.
Copy. R7, R8. Correct?
That's affirmative. R7 and R8. And you can start with whatever one is convenient. Frank, just for heads up, when you are in the bag, you're going to retrieve the AET with the AMS knob on there.
Okay, copy that.
Frank, with that moving anchor of my safety tether, just want to make sure that now I can get it off to my left. It's currently open my right.
Yep.
So I'm going to do...
It's clear. Just see it. Yep, oh,
Yeah.
That'll work. Keep going. Bring your legs down. Keep going down on your legs. Good. You're clear.
Awesome. Perfect. Thank you.
Yep.
The two spacewalkers now will tighten a pair of hinge restraint bolts to make sure that the unfolded ISS rollout solar array does not have any motion at the hinge itself. We're 3 hours, 40 minutes into the spacewalk. The crew continues to work slightly ahead of the timeline. Everything proceeding in excellent shape.
Okay, R7, R8. I am here and understand we're going to drive this clockwise.
That's affirmative. Alpha 1.
These bolts that the two spacewalkers are driving will physically attach the iROSA to the mast canister that basically also is the base, if you will, for the original solar array on the starboard fore truss of the International Space Station. The iROSA now will accompany that original array to increase electrical output for the 3A power channel.
Okay, Alpha 1, clockwise 2 is set.
That's good settings. And so you're going to drive those hinge bolts 14 to 16 turns. Just let us know which one you're starting with.
Copy. So it was 14 to 16?
That's what I heard.
And based on that body position in the pool, that might be a position that Frank can help stabilize you a little bit.
That sounds great. Understand 14 to 16 turns, correct?
Affirm.
Here. Knock it down. Oh, we just missed it, the power. Okay. It was on, but I think we just expired our 50 or 45 minutes. Okay, just to say it again, Alpha 1, clockwise 2.
Those are good settings.
I'm going to try to put my feet here, and if there's a way you could stabilize my shoulder, we shouldn't get too much torque into the sky. Okay. You want higher? Nope, it's good. 4. Okay, good green light. Actual torque of 2.4, and I had 17 turns.
Copy. That's a good R7.
Sorry, I didn't tell you which one I was doing. That's for that Hecka. All right. That leaves R8, and Frank, if we could do something similar. Okay. I see a little bit parallel with the mod kit. That's perfect. Thank you. Okay, 17 turns again. The green light and actual torque of 2.3.
Copy. That's a good R8. So now we're going to work to try to release them one turn. So the new setting is Alpha 1 counterclockwise 2.
Alpha 1 is set. Counterclockwise 2 is set. And I'll try to go get R7 first here, and we're doing turn or less, correct?
Copy. One turn or less.
There's 3/4 on R7, comes R8. 3/4 on R8.
Copy. A good release on both R7 and R8. You can stow the PGT, and then Frank's going to hand you that AET with the AMS knob and cap keeper.
Copy. Okay. This, thank you.
And there's two reds on there, so you should just be able to use it as is.
And Frank, there should be enough stretch that you can just leave it retted.
Affirmative.
All right. On hand tight on R7.
Copy, that's going to be less than one turn, less than 30 inch-pounds.
Hey, that's less than 30 inch-pounds, and that was about half a turn.
Copy, Josh. Good R7.
R8.
A good look at the solar arrays at the starboard fore truss of the International Space Station, 112 feet long, 39 feet wide, about to be augmented by the ISS rollout solar array, which when unfurled will be about 60 feet long, providing an additional 20 kilowatts of power for the 3A power channel on the International Space Station.
Safety cutter on my left side, and now we're moving around. Just make sure, I think it's still in a good config.
It is, yep.
Awesome. All right. I am on the capkeeper hook for, this must be J4.
J3. No, J4, correction.
Okay. Sounds good.
Sorry, I saw your end effector.
Yeah, that's okay. I do need to move that for sure. Okay. J4 is off. And let's put this, that's a lot going on there.
I'll just grab a handle of the scoop.
Yeah. Oh, I see what you mean. Yeah, it might. That's okay. That's super sure.
Here it is.
Thank you. That sun is something, huh?
Mm-hmm.
Here comes J3. That might keep happening, Frank.
Yeah, I'll put it on for you.
Oh, sweet. Oh, okay. Sounds good. And then the next one, let's try to do all four in the same area. That doesn't really matter. There's plenty of hooks, right?
Yeah.
That is awesome. Thank you. All right, Nick, that's 4 caps for J1 through 4.
Nice.
Then I think we'll do MVGLs, right?
Yep. Copy, Josh. Good release on those caps. And just a heads up, your head is pretty close to the iROSA blanket.
Thank you. Way out of the sun. Egress is already attracting it.
And so we're going to use the cap keeper from the bag and get the caps on the pre-routed cables now.
You can grab yours first, view.
Sure. Good idea. I do. I have it.
Hold it here for me.
Yeah. Clear by iROSA, right?
You are. Yep.
forward over center now. Coming aft. There's full forward. Yeah, that's full aft. That's clear over center. Do you agree?
Yep. No, I think it creeps back on you. It's got to go back a little further.
I want to force it. I'm showing that guy's over center. That guy's over center. That's a good view in the heck of there, Nick.
Yep, we're watching.
I don't want to force it here. Got a good V-mate. I'm seeing 2 over centers. I go ahead and try to remove the cap. Doesn't want to come any further aft.
And Josh, if you need, you can pull on that back shell to help actuate that.
Thanks, Nick. I just did that. We are full over center. That was great training. It's quite a Medusa, huh?
Yeah.
Right. We got a calf keeper on it. That back shell was super helpful when I did it. I remember these being so hard inside. Left over center. Okay.
All right.
Go. Hey, Nick, 3 and 4, or at least the connectors for 3 and 4 are demated.
Copy, Josh.
Approaching the 4-hour mark in the spacewalk, Cassada and Rubio are working with a number of electrical connector caps. Prior to the time that we would move into an eclipse period, we will not do any electrical mating or demating of cables during daylight to ensure that the integrated electronics assembly and the solar arrays that exist on the space station are not electrically charged at the time that that delicate work is taking place. The ISS rollout solar array is bolted into place on the starboard forward truss of the International Space Station. It has been unhinged or unfolded into its unfolded position, and now a series of cables will be connected to mate the new augmented solar array to the existing solar array on the starboard forward truss, ultimately to produce about 20 additional kilowatts of power for the 3A power channel on the International Space Station.
Forward, over center, and mated on 4.
Copy, good mate.
For P3, left over center, no FOD, no bent pins, good EMI band, and going on.
Good checks, you're good, mate.
3. Full forward over center, mated on P3.
Copy, good mate. Good connections on P3 and P4.
So does not want to come off.
Right, but I recommend that back shell thing that Nick was talking about.
Yeah. Pushing.
Yeah, Frank, if you hold the cap in one hand and the back shell, the metal part of the back shell in the other, and just try to separate them, it should move the lever by itself.
Ah, nice.
Understanding what you're saying is key. Thank you.
Hey.
All right.
Do you want to get these, or do you want me to mate them and...
Okay.
Okay.
All right. So Papa 1 is going to J1, is that correct?
Affirmative, Papa 1 to J1.
Hold on. He's going to want the pins and...
Yep. All right, thank you. All right, I have good pins, no fraud, my band.
Good checks, go to mate.
I think what worked for me is getting it right there, and then I took my thumb on top and breathed on the structure.
Okay.
Yeah, did you already get it?
No, well, I just did what you did. Yeah,
oh,
kind of close. All right, thank you.
Made it look easier.
And P2 to J2, and I have good pins, no fraud, good EMI band.
Good checks, go to mate.
Do you want me heading over to 2217?
That's affirmative, Josh. You're good to go over there for your tether swap.
Okay.
And that's both P1 and J1 are full forward over center.
Copy, good connections. So Frank, you're going to start working the M bolts, starting with M31 through M34.
Frank, that the safety tether's still looking okay, correct?
Wait one. That's it, looking.
4 hours into the spacewalk, Frank Rubio is going to begin to drive a series of 8 bolts, 4 on the left side, 4 on the right side of this mounting bracket, to firmly secure the ISS rollout solar array, permanently affix it to the integrated electronics assembly on the International Space Station's starboard fore truss.
Look, I am Nick, I am ready for settings.
Hey guys, we're back with you off a short handover. Just wanted to provide you with a big picture as you're moving into position for the next task. From a consumables perspective, you guys are golden. We've got plenty of time. You're on track for the timeline. So we're going to work these bolts. We're going to work the cable as a priority. When we get into Eclipse, we'll mix in the cables as we need to. Then we'll step into the deploy, and we're completely on track for trying to get after 1 Bravo. So you're doing great.
Thanks a lot, Nick, for the heads up.
Sounds great, thanks, Nick. I am ready for settings.
Copy. You've got Bravo 5, clockwise 2.
Spacecraft communicator Nick Hague reporting back to the crew a status and the big picture. The 1B cable that he referred to is one of 4 electrical connectors on the adjacent starboard 6 truss to which this ISS solar array, the rollout solar array, is attached now and will soon be unfurled. Back in March, there was a trip, an electrical trip. You could call it a short in the circuitry of the 1B power channel on the starboard 6 solar array that took down some of the power capability of the 1B solar array, the 1B power channel itself. The array had been operating at a somewhat reduced or degraded capability until about a week and a half ago, when there was another electrical trip that further degraded its capability and took down the 1B channel altogether. All of the electrical loads for systems usually powered by the 1B power channel went over to the 1A power channel seamlessly, so there was no interruption in space station operations or payload or utilization work. However, in order to get the 1B power channel back up and running at about 75% of capability, the two spacewalkers are going to disconnect one of the 4 electrical connectors between that 1B power channel and the integrated electronics assembly on the starboard 6 truss, isolating the affected area of the solar array, and then the 1B power channel can be reactivated to about 75% of its rated performance. The 1B power channel is going to get its own ISS rollout solar array next year, when the next pair of solar arrays are launched on another SpaceX Cargo Dragon's resupply flight.
Okay, make that 5301. You would, Nick?
Copy 5, Josh.
Thanks, man. Okay, tether swap first or APFR reinstall?
We'll work the tether swap, and then we'll do the APFR reclock.
Okay. Sounds good. All right, Nick, I'm going to go get my red hook here on 2217. I'm going to put a red on it. And then I'm going to put it on my right gearing. I'll lock it out first.
Copy, Josh.
All right, red hook is down on my right gearing, center gate closed, slider lock, black on black.
Copy, Josh. Good configuration.
On Mike 31, or correction, on 31, I have 3 Mike 21.9 on the torque, and I was 13 turns.
Copy, Frank. And from the HECA view, it looked like it might have been turning a little slow. Just want to confirm settings that you're clockwise 2.
I thought I did. It's with a clockwise 1, so apologies.
Yeah, no worries. And can you see black?
Correct. Yeah, black line is flush on that one.
Okay, copy. No, we're good with that bolt, so you can move on.
Copy.
red reel is unlocked, so I understand I've got to go to just grab my anchor from my left safety tether off the SSR vest.
You've got to go, Josh.
I make on 32, I have 13 turns, green light, 22.2 on the torque.
Copy, Frank. Good bolts.
Now black line is flush.
Nick, I'd like to start with yaw and roll if I could, since I'm right here. I think it's going to get further away from me later in the process.
Okay, yeah. So it's kilo 9 for yaw and roll. The pitch is foxtrot, foxtrot.
Okay. I'll come back to the pitch. I understand kilo 9 on roll and yaw.
Yep, copy. Kilo 9er.
Thank you.
On my 33, I have 12 turns, green light, 22.3 on the torque.
Copy, Frank. Good bolt.
Black line is flush.
Copy, and we're following along in your Hecka.
Okay.
All right. Yaw is 9. Roll is kilo. Going for pitch.
Foxtrot, foxtrot.
Okay. I'm sorry I lied to you. I'm going to do clocking first and then come back to foxtrot, foxtrot. I think it's a clocking at 9. Is that correct?
Affirm. Clocking 9.
All right, I've got a mini workstation ret on the APFR. 1, 2. Trying to get to on black.
And make on my 34, I have 12.5 turns, green light, 22.3 on the torque.
Copy, Frank. That's a good bolt. Hey, before you move on to the right side, you were working around the mod kit strut there. There's a lot of MOI. I just want to give it a chance to wrap that strut back up if anything came loose.
Okay. Can I do it when I come back to the bag?
Affirm.
Four hours, 14 minutes into the spacewalk. Frank Rubio working with Josh Cassada. They've completed the bolting of the left side of a series of 8 bolts, 4 on each side, that will permanently affix the ISS rollout solar array to the integrated electronics assembly on the International Space Station's starboard fore truss.
Okay, there's a clocking of 9. I got 6 facing me, which I believe is true. And I got a good pulse twist test, and I'm black on black.
Copy.
I'm going to grab my rep back, and then I'm going to go for Foxtrot on pitch.
And Mike 35, I had 13.5 turns, green light, 21.9 torque, black line is flush.
Copy, good bolt. And Josh, as you adjust that pitch, you also want to, if you got an opportunity, lay that Ingress aid flat.
Okay, thank you. How do I like this APFR better than that other one? We're in lock, and pitch can be depressed. I'm going to go full down the Ingress here.
Copy, Josh.
Any chance we could someday bring that other one back in for some onboard maintenance? Maybe I'll just put that on the comment card for the day. Okay. Nick, I think we've got a good config on the APFR at the SSRMS, if you agree.
Yep, we see the same. And so when you're in a good position and clear the arm, you can give Duke a go for the back off.
Okay. Just give me a minute or two, and I'll be out of your way.
Copy, we're standing by.
Nick, on Mike 36, I have 12.5 turns, green light, 21.9 on the torque, and black line is flush.
Copy, that's a good bolt.
Okay, Duke, I'm on the starboard side of the IEA. My safety tether is clear. She has a go to back off if you'd like.
Okay, we copy that your tethers are clear and your APFR is reconfigured. We are going to maneuver to the IEA back off position.
Copy.
Mike 36, 12.5 turns, green light, 22.0 on the torque, black line is flush.
Copy, good bolt, Frank.
Okay, EV1, we are starting our movement nadir of 50 centimeters, starting motion.
EV1 copies, and I'm over at the mod kit, and I do not have SA on the arm.
We have good clearance.
Okay. Nick, I'm back at the mod kit.
Josh, can I hand you this PGT and you grab that bolt that's over there?
Sure.
It's on the other end of the...
Give me 1 second. I wasn't listening to the settings. Do I need a BRT?
No, it helps. Yeah.
And which one am I doing?
Just that one right there by your right hand.
Yep.
Mike 38.
Give me a second to get my BRT down, and I'll be ready. I'm going to grab this one on the far right here, as you probably heard.
And say again, Josh.
I'm getting this far right bolt here. I can't really see the label.
I Pike 38.
Pike 38,
Yep.
Frank says.
Yep, M38's the only bolt over there.
Okay. All right, I've got Bravo 5 and clockwise 2 set.
Good settings. 11 to 13 turns. Looking for a black line.
This is the last of the 8 bolts that will permanently affix the ISS rollout solar array to the starboard fore truss of the International Space Station.
Talk me onto it. Just symbolize in the way.
Yep, it should be.
There it is. Hold on.
Yep, perfect.
It's a tough spot.
An MOI does not help.
Nope.
One iota.
Cables are 32. Okay, I'm on it. All right. Certain turns. Oh, come on.
It'd be 11 or 14, but it's been about 12 or 13.
It's not turning, so it must be out of ready. All our air, so this is the one you were talking about.
Yep, it might be just one of the clockwise. 2 might just be slightly out of.
Clockwise 2. One.
All right, man, I didn't know it was not going to be that involved.
That's okay. And I got a red light. That's 13 and a half. Actual torque is 4.3. That doesn't sound right.
Yep, copy, Josh.
A good view of the ISS rollout solar array that has been installed on the starboard fore truss of the International Space Station. Now 4 hours, 22 minutes into today's spacewalk by Josh Cassada and Frank Rubio.
Display is not in front of me, but I saw 22 as the program. Yep, that sounds right. And starting turns again. Zero torque and 0 turns. Maybe it just got reset. Looking for a go to do it one more time. I do have a black line.
You have a go?
Although 5 twice. Is there any way you can pull these down, Frank? Probably.
Okay. So unfortunately, the cable tie's got him up there.
Yeah. There we go. All right, certain turns again. Okay. Green light, actual torque 21.9, and that says I got 0.3 turns. I didn't even see that.
Copy, Josh. That's good. That's a good bolt.
So, sounds good. And again, that black line is flush. All right, Frank, what does that leave?
That's all of those bolts.
So, you want us heading to R9, R10, or do you want us going to cables?
Hey guys, big picture. We've got about 18 minutes till eclipse. We're going to work on some cleanup steps here with the M bag, and then we're going to get in position for cable mates during eclipse.
Perfect. And then we'll deploy after that.
Affirmative.
Okay, sounds good.
Spacewalk communicator Nick Hague letting Cassada and Rubio know what the big picture is here at the 4-hour, 25-minute mark. The ISS rollout solar array permanently affixed now to the starboard foretruss of the International Space Station. The crew will do a little bit of cleanup here, waiting for the start of a nighttime pass about 17.5 minutes from now. It is during that nighttime pass that there will be a mating of cables that will electrically connect the new ISS rollout solar array to the integrated electronics assembly, joining the solar array that currently exists, the original array that was delivered 15.5 years ago on the STS-117 mission of the Space Shuttle Atlantis. Each of the ISS rollout solar arrays will produce an additional 20 kilowatts of power to augment the research and utilization capability on the International Space Station.
And Josh, if you want to help Frank, he's going to end up taking that scoop off the mod kit.
Oh, absolutely. I was thinking that might be useful for doing 9 and 10. It was really useful for doing 7 and 8.
The choreography and the timing of the mating of these electrical cables is designed to be done in darkness so that any stored electrical energy in the integrated electronics assembly doesn't pose a hazard for the crew members. Again, we'll go into eclipse about 16.5 minutes from now. It'll be about a 28.5 minute pass through an orbital sunset before we come back into daylight to begin the actual unfurling of the array to its full length of 60 feet and its ultimate tensioning.
Nick, it is tethered right now. Do you want me to take the time and I can try to get it sticking straight out?
If you wanted to try to release it and get it reclocked into the straight-on position so it doesn't provide interference, you can give it a shot.
Actually, if you can see in my HECA, I think Frank was brilliant. I think this is a great orientation. I can get both with no interference.
Yeah, we see it in the HECA. You're right. So if you want to leave it there, it's your preference.
Yeah, let's do that. Don't mind.
Copy all.
No, Miranda, I still appreciated those scoop lessons.
I help you, Frank?
Nope, I just finally went with my right D-ring extender here. So that 55-footer is on my right D-ring extender, gate closed, hook lock, black on black.
Copy. That's a good connection, Frank.
Thanks, Josh. Appreciate it, man.
No problem.
And so, Josh, words for you. So Frank's cleaning up over there. If you think it's helpful to have some hands there, you can assist. Otherwise, next task will be getting into position for the cable work on your side.
Sure. Frank, put me to work if there's something I can do to help. I don't know.
No, I'm just going to stuff everything back in here. I'm trying to keep pre-position something. Should be pretty quick to get this in there. Thank you.
Oh, okay. I know that idea, or what was it, the strut bag last time was
a bear.
It was a bear.
Yeah.
So I'm happy to repay the favor.
Let me give this 2 minutes and then see.
Okay.
It'll not be pretty, but it's going to be in there.
And Frank, just a heads up, we're going to end up opening those doors again. So if you can't get everything in, we can move on and deal with it later.
Are we, okay, we're opening them back up today?
Yeah, so that scoop that Josh wanted to leave in position is going to go inside.
Oh, okay, then I'll just leave it open.
Well, we actually staged that ret, we staged the end of that ret on the outside. So we actually aren't going to have to open up the doors for more than a second.
Okay, I'll close it up.
Can I come over? Invitation only to the left side of the mod cave?
Yeah. I think I just got it.
Awesome. Dude, you're awesome.
Yeah, by just got it, I mean almost just got it.
You think you'll get it? I might head over and,
Yeah, go for it. If not, we'll get it together later.
Oh, no. I'm not leaving it.
Sure.
You got it.
Yep.
Did you get it?
Yep.
Perfect.
Not perfect,
Nice work,
but we're
Frank.
going to open it back up, so. Thank you. So head over to the panel.
Yep, so as you guys can tell, the sun's getting low on the horizon. We're about 10 minutes away from the start of our working eclipse. So if you want to get in position, we're going to sit here and wait. About the only thing we can do is demate the wingtip connectors, the cables from themselves.
Well,
Yep, and we've got some time, so I'm going to read the warning to you, is that you cannot demate the SAW connectors until eclipse plus 2 minutes. We'll let you know when that is. And that you must maintain a 1-foot keep-out zone from the demated SAW connectors starting 2 minutes prior to and during installation.
1 copies.
82 copies.
This is Mission Control Houston. We're about 9.5 minutes away from entering the eclipse period, a period of orbital sunset and darkness, during which Cassada and Rubio will begin to mate cables, electrical cables, that will provide the electrical connections for the newly installed ISS rollout solar array that is now permanently affixed to the starboard forward truss of the International Space Station.
Take them off, put it on the handrail, and then put the cables inside?
Sounds like a good plan.
Okay, North.
I feel bad about this, Frank. You worked so hard on this one.
Nope. Okay.
Hey, Josh, is there a wire tie further outboard?
There is. It's on the long handrail.
Yeah, copy. That's the one we want to try to release.
See? This one isn't attached to the strut handrail. Do you want it to be?
Hey, firm.
Oh, I'm sorry. It is. It is. I'm sorry. It's hiding behind the cables. I see it now.
Once we enter the period of eclipse or orbital sunset, there are a series of 4 connectors, 2 for the left blanket box on the integrated electronics assembly, 1 and 2 for the right blanket box. Cassada and Rubio will divide and conquer, each taking 2 connectors apiece, and that will electrically mate the new ISS rollout solar array to the electrical system of the International Space Station.
Affirmative.
Affirmative. Nick, verify I can go ahead and demate the cables from themselves.
Yep, you are go to demate those new cables.
Copy.
Nick, understand I am not putting these cables back in this long handrail. I'm sorry, this long wire tie now, but do it after the mating.
Yeah, copy, Josh. Yeah, so it's there. After we finish the mating with the cables, you'll use that to help clean up some of the slack.
Okay, sounds good. So it's on the long handrail now, so I'm going to take off my ret and we'll use the wire tie later.
Copy.
Okay, P23 Alpha is demated from J23 Alpha.
Copy, Josh.
And same for A9 Alpha and P9 Alpha.
Nick, I have P7 Alpha and J7 Alpha demated. I'm just going to do them one at a time.
Yep, copy, understand. Both of you guys are in a great position. We've got about 4 minutes before we can actually start working on those connectors. We've got some inhibits to put in place, so get into a good position and catch your breath. Great work.
Sounds great. Thank you, Nick, for getting us here. Holy cow. Nick, while we do catch our breath and take in this incredible view, after these are mated, understand we're going to go back to the deploy 9 and 10, and then Frank will hang out for a couple minutes and then start making his way to S6, is that right?
Yep, copy. And as efficient as you guys are, we may have to pause a little bit because the deployment needs to be in sunlight.
Okay, copy that.
I bet you say that to all the EVAs.
We're only efficient because of the plan that was put together. It's remarkable. And the team that got us out of the door on time worked out really well.
Hey guys, well, we got a couple minutes here while we're waiting. It looks like you're in good body positions based on HECA. Just to let you know, you can drop a BRT on handrails there if you want to get stable if you haven't done it already. And then when we are working the electrical connectors, we're looking for the checks on both connectors.
Copy.
Copy that.
Four hours, 42 minutes into the spacewalk. Frank Rubio and Josh Cassada soon will begin the mating of electrical cables, 2 on each side of the integrated electronics assembly, 2 for the left blanket box, 2 for the right blanket box that will electrically tie the new ISS rollout solar array to the original solar array delivered 15.5 years ago to the International Space Station.
Just to let you guys know, right as we give you the go to start work, I'm going to end up being in a 20-second handover.
Okay, understood. After P9 Alpha goes to the panel, and P23 Alpha go to the panel, can I do those in parallel, or does P9 need to get complete before P23?
Yeah, and copy, and we're still putting in some inhibits, but we'd like to do them serially, so we'll work everything on one cable and then move to the next. Okay, guys, we are go. So, Josh, you're good to demate P9 from panel P9, and Frank, P7 from panel P7.
7. Okay, P9 work. 9 is demated.
7's demated.
Copy. And it's P9 Alpha to the panel P9.
And we're in that handover between satellites. As you just heard from Nick Hague, the Spacewalk communicator. We'll pick up video here in just a moment as the mating of electrical cables between the newly installed ISS rollout solar array and the International Space Station's S4 truss electrical system begins.
I have a good EMI band, no FOD, and good receptacles.
All right, and I'm mating P9 Alpha to panel P9.
Copy. And Frank, we were in and out with a handover. I copied all your checks, Frank. Josh, I'm sure you checked as well. Your go to mate.
And those checks were completed. Yep, you got it. P9 Alpha is mated to P9.
Copy. P9 mated to the panel, or Alpha to the panel, and you got a good hard stop.
Sorry, yes, I did get a good hard stop, and it is the panel P9 that I mated to. That's correct.
Okay. And so you're going to mate J9 Alpha to the SAW cable P9.
The SAW cable referenced by Nick Hague is the solar array wing cable.
Demated. And no pins, no FOD, and good EMI band on the SAW cable and on J9 Alpha. No bend pins, no FOD, no EMI band.
Copy, Josh, and we see it in HECA. Good checks, you're good to mate. And copy.
Go to mate, thanks.
You're go to mate, Josh. And Frank, you were able to mate P7 Alpha to the panel.
Affirmative, good hard stop.
Copy, good hard stop. So you're working J7 Alpha to the SAW cable P7.
Affirmative, good checks on both.
Good hard stop on J9 Alpha to SAW cable P9.
I have the same.
Copy, good connections. So Josh, you're working P23 to panel 23 D-mate, and Frank, you're working P21 D-mate from panel P21.
Copy, P23 for you. 23 is demated on the SAW cable. Good EMI band, no FOD, no pins. And on the panel, no EMI band, no FOD, good pins.
Copy, Josh, good checks.
And Papa 21 is demated. Good pin, good EMI band, no FOD on the original cable. And for the 21 alphas, also have good pin, good EMI band, and no FOD.
Copy, Frank, good checks. Your go to mate P21 Alpha to the panel.
Copy, good work.
I don't know if I told you the words on P23 Alpha. Good EMI band, no pin, and no FOD.
Copy, Josh, your go to mate P23 Alpha to the panel.
Copy, thanks. P23 Alpha is mated and hard stop on the panel.
Copy, Josh. Next one will be J23 Alpha to the saw cable P23.
The saw cable P3, and I gave you the words on that one. Again, I might have already done this, but J23 Alpha, pins, no EMI band, and no FUD.
Copy, good checks. Your go to mate, J23 Alpha to P23.
Okay. P23 is connected to J23 Alpha.
Copy, Josh, and just want to confirm. Yep, there you go. And so now you can work on cleaning up the cable slack.
Okay. I don't know what you're seeing, Frank, but I'm not seeing enough slack to get out to that long handrail.
No. If we go to the mix truck. Maze.
So the long wire tie that I attached out there, do I need that?
And Josh, you don't have to worry about trying to get to that the wire tie out there on that long handrail if it's not going to be helpful. You can just use the wire tie on the mid strut.
See, I think you can see in my HECA, I don't know that it needs anything here on the mid strut if it's already connected, but I'm happy to do what you need.
And copy, Josh. Let us look at your HECA and talk about if they want anything else.
Okay. In the interim, do you want me to go out to the long handrail and get that long wire tie?
Yeah, Josh, actually what we'd like you to do is we're okay with those cables for now. Frank is having some difficulty with the panel connection, and so we'd like you to go over and see if you can help stabilize him a little bit, and that'll help free up his hands.
Sure, absolutely.
And copy, Frank, you've moved on to J21 Alpha to the saw cable P21.
Yep, I'm just going to get these two real quick.
Okay. Just want to double check a good check. And guys, just want to let you know we've got almost 20 minutes left in this eclipse. You're working super fast, so we've got time to work through this.
Okay, copy that. Oh, thank you, Nick.
So it's the panel one, is that right, Frank?
Well, it's the one that's been taking my rear end here.
Rubio working to connect the fourth and final electrical cable that will mate electrically the newly installed ISS rollout solar array to the 3A power channel source on the S4 starboard array of the International Space Station. Rubio working in tight quarters there.
Okay. I haven't quite been able to. It's helpful if I hold you right here. You tell me when you want to stabilize, and I'll help you. Sure. Got it? Awesome. You need to twist hands. I still have one more.
And Frank, just want to confirm good hard stop on that one.
You can mate with your left. It was a good hard stop.
Copy.
You're able to mate with left or with your right? Well, on that one I was. You're amphibious. Something like that. All right, and good hard stop on.
Okay. Copy that. Good hard stop on J21 Alpha to the saw cable P21.
Alpha 21 to joint.
Well, the cables now have been mated.
Excellent work, guys. And so if you want to work on cleaning up the slack on the cables.
Thanks, Josh, for your help. I didn't do much to hold you back. Nicely done. All right. And Nick, what do we need to do with the slack on the right side?
Yeah, Josh, for both of you, when you're cleaning up these cables, what we're trying to do is just prevent snag hazards when people are translating by. So it's going to be your call to try to shore up any kind of potential snags and tidy them up.
Okay, copy that.
No more constraints now to working during the eclipse period of darkness. We'll come into an orbital sunrise in about 15 minutes, at which point there is one final step before the unfurling of the iROSA array, that being the release of a pair of launch restraint bolts that will basically remove all the stored energy in the rolled up array and allow it to begin to unfurl to its full length of 60 feet, followed by the driving of 2 bolts that will provide the tensioning for the array that's required.
I do not have a good solution over here. I think it's about as good as it's going to get. I twisted mine enough when I was working them that it actually ended up in a piston sig. Yeah, I got one nice little loop. All right, Nick, I have a good config here on the left.
Copy, Frank. And so we're going to have you do a glove, hap, and gauntlet inspection. And we noticed the cuff checklist has slipped down again, so we may have to have the two of you come together to help work on shimmying that back up your sleeve.
Okay. I can push it here. to have the gauntlet cover the ring.
Yeah, and Frank, if you can just flip the pages back and pull the gauntlet up over the wrist seal, then you're good.
Yep, just did that.
And Josh, ground's happy with that.
This is Mission Control Houston at the 5-hour mark in today's spacewalk. Josh Cassada and Frank Rubio have sailed through most of the work associated with the installation of the first of the 2 ISS rollout solar arrays delivered last week on the SpaceX Cargo Dragon resupply mission to the International Space Station.
Josh, if you can give me a glove, hat, and gauntlet check, and then Frank, I don't know if I copied your glove and hat.
Nope, I looked at them and didn't tell you. My gloves, no changes, dry hat, good gauntlets.
Copy, Frank.
After removing the iROSA, as it is called by its acronym, from its flight support equipment, Josh Cassada rode the end of the Canadarm2 robotic arm holding the 750-pound in mass rollout solar array over to the starboard 4 truss work site, where he and Rubio worked to bolt it in place, first mounting it on a mounting bracket that was installed on a previous spacewalk, then bolting it in place, and then just moments ago completing the connection of 4 electrical connectors to electrically mate the new array to the power system for the 3A power channel on the International Space Station. We're about to move into an orbital sunrise, at which point the crew members will release a pair of launch restraint bolts that will begin the unfurling of the array to its full length of 60 feet, and will drive 2 tensioner bolts to provide the tensioning of that blanket, basically at its full length of 60 feet.
Launch restraint bolts positioned to stay clear of the deploying iROSA blankets.
EV1 copies.
EV2 copies.
Frank, Josh, just give you a heads up, it's about 10 minutes before we're going to get into the sun and be able to deploy this. So we've got a little bit of time as you look around. If you see any MLI that on the mod kit or anything, now's the time that we've got a little bit of time to clean up.
Copy that.
All right, Josh, I bailed on you before. Yeah, we'll help with that.
Once we complete the unfurling of the array and the tensioning at its point of 60 feet in length, iROSA will be complete, and then we'll have to wait for the next eclipse, which will start in about 1 hour and 13 minutes before the crew can tackle the other major task that was added to the back end of today's spacewalk, that being the demating of a single connector on the adjacent starboard 6 solar array truss. The 1B array incurred a power trip about 10 days ago that took the power channel down for the starboard 6 solar array, the 1B power channel. The power loads, the electrical loads powering systems on that channel were seamlessly transferred to the 1A power channel without impacting any space station operations. But to regain the use of the 1B array, one electrical connector needs to be demated. That has to be done during an orbital sunset or eclipse in order to isolate the affected area of the solar array, the 1B solar array, out on the starboard 6 truss. Once that cable is demated, then the 1B array or the 1B power channel can be reactivated to bring its power capability up to about 75% of performance. That 1B channel is awaiting delivery of the next pair of rollout solar arrays, iROSAs, on the next SpaceX cargo delivery mission that will bring iROSAs up. That is targeted for SpaceX 28.
Okay, I think I've had my fill of MLI.
You guys got about 5 more minutes.
Sounds good. Thanks, Nick.
And Josh, looking at you trying to BRT there in the pool, it was helpful. There's a handrail on that the strut that's just off to your left. Might make it for a decent BRT position. Your call.
Okay, copy that.
That looks good.
I think that might work okay. You're right, that the handle works really, really well too.
And Frank, Josh, got a few more minutes. It's like watching water waiting for it to boil.
No sweat at all. It's a great place to do it.
Also much better to be in this position than to be rushed to try to beat the sun.
Yep. Very exactly right. And people thought through every single scenario to get this window. Incredible. Lisa and Monday and Miranda. Nick, I just put the PGT on there because that's an easier place to put it, but I know we got to wait. And I understand Bravo 7, not sure on the counterclockwise.
Yep, I hadn't passed it up to you. So it's Bravo 7 counterclockwise 2.
I guess right. I got Bravo 7 set counterclockwise 2, and we'll wait.
Yep, and it's going to be 17 to 20 turns.
I'm on R9 here.
Tally. And when these release, they show a white line.
20 turns. Copy that.
And Frank, while we're sitting here, in the procedures, it's got a reminder here, you know, the target that you're trying to look at as this deploys is that those initial magnets as they snap together at the base of the boom. That's the item of interest.
Yep, and those will be in the middle section, right?
Yeah, so it's located on the...
Just directly over that hinge point?
Yeah, negative. It's on the outside, so it's on the very ends of the boom, and it's rolled flat, and you'll see them fold back and make that tube. And it's the thing we kept yelling at you not to touch that has the white skirt.
Okay. Yep, I see it. Hopefully you guys have a good view on the Hecker.
And Heck is not required for it, so as long as you can put good eyes on it, that's good.
Okay.
This is Mission Control Houston. We're nearing the point where we'll fly into an orbital sunrise. We are just about off the southwest coast of Australia right now. When we come into daylight, that will be the cue to begin the deployment, actually the unfurling, if you will, of the ISS rollout solar array that has been installed on the starboard foretruss of the International Space Station, joined now electronically to the original solar array on the S4 truss of the station that was delivered 15.5 years ago to the International Outpost. The crew will release a pair of launch restraint bolts, and then the stored energy in that rolled up solar array will be released, and it should unfurl. It will take a few minutes to unfurl to its full length of 60 feet, at which point Josh Cassada will drive and release actually a pair of bolts to tension the blanket, and the iROSA work for the day will be complete.
Nick, I'm at the edge of the IEA here. Do you want me to kind of go in the middle of it, or?
We'd like you to work outboard of the mod kit, so you're going to translate further outboard.
Correct. Yep, but I came all the way to the, I guess, edge of S5, or S4.
Yep, so we want you to translate out to S5. So if you head back in out there, you'll be in a good position.
Got it. Okay. By outboard, you mean outboard. Problem with being upside down.
Okay, Josh, you have a go to work on the first bolt.
Okay, R9, Bravo 7, counterclockwise 2. I heard 17 to 20 turn.
That's a good readback, and you should see a white line fully appear when released.
This is the first of 2 launch restraint bolts that, once both are released, will begin the unfurling of the iROSA.
Yeah, affirmative. Handrail would be 2101 is something that worked in the NDL.
Okay.
And we're in a quick handover between satellites, so we'll get back momentarily our downlink video from the space station.
There's 18, and I see a white line.
Copy, 18 turns, white line on R9. Good bolt.
Got it.
And we had a little...
And standing by for your go on R10.
Yep, copy. And Frank, are you in position? We had a quick handover there.
I am at 2101, 2102.
Copy. Okay, Josh, you are go for R10.
Bravo 7, counterclockwise 2, R10. 17 to 20 turns. Alright. Not quite popped out yet. I'm at 21 turns. It just needs a little persuasion.
Copy, Josh. That's expected.
Okay with it, Nick. I'm going to put a couple more turns on it.
Yep, your go. You can't overturn it.
Okay, sounds good.
Turn to move.
And applause here in Mission Control. The rollout solar array begins to unfurl. This will take a little under 10 minutes to reach its full length of 60 feet.
That is incredible.
That's pretty cool.
Oh. Amazing job from the engineers who came up with this idea and the ones who put together the plan. This is remarkable.
The ISS rollout solar array began to unfurl at 11:37 a.m. Central Time at the 5-hour, 21-minute mark into today's spacewalk.
Okay, Nick, the first set of magnets are all clipped together.
Yeah, copy, Frank. And if you could roll a little bit to your right, we'd might help us see it on your HECA. That's a great view. Appreciate the effort.
Yep.
This array, when fully deployed to its length of 60 feet, will shadow about half of the original array on the starboard fore truss, providing an additional 20 kilowatts or so of electrical capability for the space station.
And Nick, from my vantage point, it looks like on this side, all the magnets are aligning and zipping up properly all the way, at least for 15, 20 feet.
That's great to hear, Frank. Thanks for the words.
This is Mission Control Houston, the new ISS rollout solar array doing just what its name implies, rolling out to its full length of 60 feet that began about 5 minutes ago.
I know that I'm really speechless, but this will do it.
That's pretty cool. A pretty amazing view to backdrop the dude, Joe.
And Josh, Frank, we've got a few minutes here as it finishes the deployment, and then we tighten everything back up and start cleaning up. Wanted to give you some big picture words and then figure out, get some input from you on the way forward, because we do have a little bit of time before the next eclipse where we're going to go after that 1 Bravo.
Okay. Ready to copy.
Yeah, so big picture, consumables are looking great, timeline's looking great, so we're not facing any limits there. We've been scratching our heads on the things that Josh might be able to do while you're out working the 1 Bravo. So that would involve going back to the FSE and releasing bolts 1 through 4, R1 through R4, and no need to do any kind of socket swap or anything. We'd have you drop a crew lock bag off on the seated cart on your way. And but that would Josh, that would put you at the FSC while Frank's getting in position out at 1 Bravo. Just want to check and see how you guys are feeling. If you're good with that plan, ground's here to support.
So you're broken, but I understand the question is, are we comfortable with me being at the FSC doing R1 through R4 on the lower while Frank is with 6?
Yep, copy. We've got some comm interference. You were a little broken, but yeah, that's the question. Are you guys good with the split?
I'm okay with it.
Nick, how long of a transmission it is if we need to do it quickly? Seems like it would be 10, 15? Maybe 10?
Yeah, we think 5 to 10.
5 to 10. Well, Frank, if you are comfortable with it, and we can go ahead and just talk through the route that I would take to get out to you. We've already thought through it. There's no questions. And I'd be comfortable with that.
Okay. Yeah, and we'll just stay in constant comm, and I'll let you know everything's going well the whole time.
Okay. Nick, I think I can picture a lot of the handrails. For me to get out there, obviously from the FSE, going under the MT, going under the starboard seated cart, going across the Sarge, would I stay stationed forward? Or would I?
Yeah, yep, that would work.
And I don't know if you have it up in front of you, but would it be the same path I took before? I know we've changed the configuration of the station. I think there were handrails like 2222. I know that I was going the right way after crossing the Sarge.
And Josh, we're talking it. Yeah, copy, Josh. It'd be nadir forward corner all the way to the FSC, or all the way out, I'm sorry.
Okay. And that was a pretty clean path, if I'm not mistaken.
It's a straight line shot, and it's per what we had sent you in the brief.
Okay. It still does have that grapple fixture, but just got one obstruction, is that right?
Affirm.
Well, Frank, I'm as familiar as you can be. Haven't looked at it on the computer, and then at least haven't been out there once, but that's not the route I went.
Yep, and if I had to come to you, I would just follow my others, swap, and then head over to the feeder cart.
I agree. Okay, Nick, if we end up going that route, EV1 and EV2 are game.
Yep, copy, Josh. Appreciate you guys talking through that. We're tracking along. Understand that anything that we've got you doing, Josh, we can break out at any time. And so if the situation changes, if we feel like we want to just stop and call it a day, you guys have crushed it up to this point. This is all extra and nice to have things.
Okay, sounds great. And this spacewalk was crushed. We certainly didn't do it by ourselves.
The new ISS rollout solar array now fully deployed to its length of 60 feet. The deployment took about 9 minutes to complete.
Oh, Josh out.
The deployment or the unfurling of the array began at 11:37 a.m. Central Time and was complete about 2 minutes ago. Two bolts now will be driven to tension the array, and then all of the iROSA work will be complete.
I'll head back up that way.
Sounds good. Okay, Nick, then I'll go ahead, Nick.
I was going to say your settings for the PGT are Alpha 1, Counter 2.
Okay. Alpha 1, Counter 2.
So the new ISS solar array joins the original array delivered to the space station at the starboard fore truss more than 15 years ago to augment the power capability and output for the 3A power channel on the International Space Station.
221, whatever it takes.
Josh, Cassada will move towards the likelihood of a get-ahead work to release 4 bolts on the other ISS rollout solar array that was delivered on the SpaceX Cargo Dragon resupply flight a week ago at the International Space Station. That array, or rollout solar array, is due to be released and transported to the port fore truss of the station for installation and deployment on December 19th in another spacewalk plan for Cassada and Rubio. This would be get-ahead work to release the first 4 bolts that are holding that second ISS rollout solar array to its flight support equipment.
Thank you for the reminder. And does this one pop out?
It will spring out when fully released.
Okay. Thank you.
Meanwhile, we're about 42 minutes from entering the next eclipse period in darkness for the station, at which time Frank Rubio will be at the starboard 6 truss and will work to demate one of 4 electrical connectors for the 1B power channel solar array that experienced an electrical trip. We're taking down that 1B power channel about 10 days ago. The loads for generation of electricity for station systems through the 1B channel were seamlessly transferred over to the 1A power channel, but to regain the 1B power channel capability at a somewhat reduced efficiency of about 75% of capacity, one electrical cable needs to be demated to isolate the affected area of that array. Rubio will demate the one electrical connector, and the electrical systems specialists here in Mission Control will reactivate the 1B power channel, bringing it back into operation, albeit at 75% of rated performance.
Good R12.
And the two bolts to tension the newly deployed rollout solar array have now been driven, so that solar array work is now complete.
Release it.
I can help stabilize you a little bit if you want. Oh, actually, you have a BRT now.
I do. Okay.
And guys, just want to let you know we're seeing good power off iROSA, so it's up and working.
Nice. Awesome news. Awesome. Holy cow. And my TTV setting is now 4.
Copy, Josh.
And that word, long awaited by spacecraft communicator Nick Hague, that the newly installed iROSA is generating full electrical power.
Thanks, Nick. I'm surprised. Oh, never mind.
Okay, so I'm going to get my mini workstation in effect. I'm going to keep that BRT down.
Okay, got it.
I'm kind of red eagle here. All right. You want to give me a rep?
Yep.
Nick, understand that we can go ahead and lease the adjustables from the cables and then Brett to the adjustable itself.
Affirmative. So both those adjustables and the scoop are going to go back inside crew lock bag M. That's your cleanup.
Look at that. All right, we've got a ret to the B-ring on the adjustable, so now I'm going to release the large hook onto the left cables. You're looking pretty hard for these earlier this week.
Yeah, seriously.
And then other hook. That's released, and it's all connected. Okay. I see you releasing the scoop and handing it to you.
I agree.
Okay. All right, here it comes.
Got it.
Sounds great.
Thank you.
Yeah, and that's the red I was telling you about on the software.
I see it. Good idea.
So Frank, that scoop and those adjustables will go inside crew lock bag M. And Josh, if you want to help him out, when it's all packed up, it's going to end up on your BRT, Josh.
Sounds great. In fact, I've got a BRT right nearby. I'm trying to make your life harder. Yeah, I'll hold that. Great.
Is that your red already on it?
That is my BRT ret. Let's just make sure that works clear and that we're happy with that being secure. Okay.
I can release it for you.
You're going to release from the mid strut?
That work?
Yeah, that sounds great. And then we'll have, there's one more down, right?
There's right here on there.
See it. All right, Nick, I'm ready for the bag on my from my BRT, so we're releasing the two integral and, what is that, an adjustable up there?
Correct. No, that was a large, small red, sorry.
Large, small. Great. It's on the bag, right?
Yep.
Here comes the integral coming off.
Okay. Let me secure it for you, just something left to snag.
Oh, that's great. With my luck, it's a loop now.
Yeah, it's true. You want me to just leave it?
Nah, it's fine. It's fine. Thank you. You can put it on. Unless it's a pain, and then we won't. Nice.
Yep.
Okay. All right. Jaws are closed. Paddles are out. I am readied. And let's tighten this guy down.
How much time till a night pass?
We got about 30 minutes until the next night pass, so we've got a little bit of time, Frank.
Oh, okay. Okay. No. Look at that. Pretty.
Funny that you mentioned it, Frank. My next task is going to be for you to take a few photos of that.
Okay, we'll try. I tried to take a few photos of Josh earlier when I was just kind of watching, and my camera did not appear to work that great, so I can still try.
Okay. And
I didn't see the shutter activating.
Yeah, it's going to be best effort.
Let's see.
And Frank, I noticed mine didn't do it at first. I really had to wake it up.
Okay.
I don't know if that's helpful or not.
Yeah, I'll try. That would have been the first time I used it, so. All right, man. You're going that way, so I'll go this way.
Nick, you want to toss me on to...
This is Mission Control Houston, 5 hours, 44 minutes into today's spacewalk. The iROSA, the ISS Rollout Solar Array, launched a week ago, along with a companion iROSA on the SpaceX Cargo Dragon resupply craft to the International Space Station. The iROSA, earmarked to augment power for the 3A power channel on the starboard 4 truss of the International Space Station, has been installed and fully unfurled, generating perfect electrical power in one of the smooth operations seen in recent spacewalking history by Cassada and Rubio. Took about 9 minutes for the array to fully unfurl once its final launch restraint bolts were backed away. Slowly but surely it moved to its fully unfurled position, and then a pair of bolts were driven to tension the blanket. And the electrical systems officer here in Mission Control reported a short time ago that the newly installed iROSA is generating perfect electrical output.
Okay, so I can start heading out towards...
With that having been completed, Frank Rubio will soon make his way to the adjacent starboard 6 truss to demate once we can move into an eclipse period, into orbital sunset. About 30 minutes from now, he will demate one electrical cable for the 1B solar array's electrical power channel. The 1B power channel experienced a power trip about 10 days ago that took the power channel down. Power output for station systems through the 1B channel seamlessly transferred over to the 1A power channel. But to reinstate power capability for the 1B channel, one of 4 power connectors will be demated. That will isolate the affected area of the 1B solar array on the starboard 6 truss. That will enable flight controllers here to reactivate the 1B channel, albeit at about 75% of working capacity. Meanwhile, Josh Cassada will do one get-ahead task. That will be the release of 4 initial bolts for the other ISS rollout solar array that's on a flight support structure on the truss of the station, on the port 4 truss. That will buy a little bit of time on December 19th when this pair of astronauts goes back out to install the next ISS rollout solar array on the port 4 truss for the 4A power channel.
About 5 panels, 5 of those solar panels up in the middle. You see 2 kind of white ribbons. There's an irregularity in the white ribbons. That's a shade. If you can take a picture of everything around that, that'd be great. We just need a handful of pictures, though. And Frank?
And so, Nick, go ahead.
And Frank, if you move a little bit further outboard, you might be able to see it between the legacy arrays through the longeron. We're just looking at that seam between the iROSA panels.
I think I see what you're looking for. Can you guys see it on the HECA?
Negative. Hey, Frank, we're happy from that vantage if you can snap some pictures.
Okay, good work. And I'm sorry, Nick, I'm here at the starboard CETA cart. Ask me again about the unbag?
Yeah, and Josh, you're going to go to the port CETA cart, and then you're going to stow the crew lock bag on the CETA cart nadir handrail.
Copy, thank you.
And Josh, for your essay, it's a temp stow because we're taking it back in the airlock.
Copy. Okay, Nick, I think I have at least 5, 10 finger pushes on the button. Not sure if I have pictures.
Copy that. Appreciate it, Frank. So if you want to, we'd like you to, if you want to move into position for your safety tether swap, and when you're doing that, we'll also do a glove and half check while you're stopped.
Okay, copy that. And those handrails again were?
It's 2006.
Okay, I'm there.
And Frank, we see you in a good position, so you're go for that tether swap.
Yeah. I make my 55-foot tether is on the outboard stanchion of 2006. It is closed. Hook is closed, locked, black on black. And again, to verify, the small hook on that is also on my right gearing extender. I see gate closed, hook locked, black on black. Okay, so I see a good load pass. Do I have a go for my right tether release?
That's a good path. You are good to release.
After that, and one.
And we've got a call out to put that down on handrail 2005.
Copy that. Okay, crew lock bag bike is on the port the cart. Okay, the right hook is on. Nick, do you copy?
Yeah, it looks like we're coming out of a handover. How do you copy?
We got you now. 82, sound clear. My right hook is on 2005 inboard stanchion, unlocked.
Copy, Frank. That's a good location, so you're good to translate outboard to the work site. Just remember to not translate up to that location via the mod kit.
Okay, copy that. No. All right, Nick, I am at the port seated cart. I've got the crew lock bag bike down there on the seated cart. Understand you need me over at the FSE, and I have not studied ahead. Am I going Alpha to Charlie?
Yeah, it should be Alpha to Bravo.
Okay.
And then it'll finish you on the zenith end, or the zenith side of the...
This is Mission Control Houston, approaching the 6-hour mark in today's spacewalk by Josh Cassada and Frank Rubio. The major objective, the installation, deployment, and activation of the first of 2 ISS rollout solar arrays delivered a week ago on the SpaceX Cargo Dragon resupply flight, is now fully activated and generating electricity, tied into the electrical system for the 3A power channel on the International Space Station's starboard fore truss. There's a good view of Josh Cassada, whose next task will be a get-ahead task to back away 4 bolts, to release 4 bolts, holding the second of the 2 ISS rollout solar arrays on flight support equipment, this time on the opposite side of the backbone on the port fore truss of the station. This is get-ahead work in advance of Cassada and Rubio replicating the work they did today during the next spacewalk that they will conduct on December 19th. Meanwhile, we're just under 20 minutes away from moving into an orbital sunset, into eclipse as it is called, at which point Frank Rubio will be at the starboard 6 truss at an electrical panel for the 1B power channel for that solar array. He will disconnect one of 4 electrical connectors, demate one of 4 electrical connectors to isolate an affected portion of the 1B power channel solar array that went down about 10 days ago due to a power trip. By disconnecting or demating one of the 4 electrical connectors, it will isolate the affected portion of that array and enable flight controllers here in Mission Control to reactivate the 1B channel, bringing it back to about 75% of its performance capability. The 1B channel itself will be augmented with an ISS rollout solar array next year on a future delivery of the next pair of iROSA solar arrays on the SpaceX 28 mission.
Those blankets on the iROSA.
Thank you. Keeping an eye on them. I appreciate it.
And just so you know, you can BRT to that handrail that you're holding right there.
Sounds good.
Yeah, both those handrails on the root beams are good.
Okay, Nick, I am at the work site.
Copy, Frank. And just to let you know, we've got about a little more than 15 minutes until the eclipse.
Okay, sounds good. I'm looking for Papa 23, correct?
And that's affirmative, Papa 23.
You're broken.
Okay, I see it. I'm going to verify. Josh, you copy me?
I got you now.
Okay.
That last one was broken for some reason. I don't know why. I understand it was Alpha 4, and it was counterclockwise 2?
Yeah, I didn't give you that, but that's the answer. Alpha 4, counter 2. It's going to be 10 to 13 turns, and you're looking for R1 and R2.
Sounds good. I see him. And you did give it to me just 5 hours ago.
True, very true.
Looks really familiar.
Can you guys see the moon and the earth and the heck of?
Is that unbelievable?
We do, Frank. Thanks for
The
sharing.
moonrise.
Yeah. Ooh.
And Frank, Josh, just for your essay, looks like we might be in and out of S-band for the next couple minutes. We should maintain lock, but it could be ratty.
Okay, copy that. Copy. Understand I'm a go for both R1 and R2, 10 seconds to swing them 90 degrees. Is that right?
Yep, that's correct. It's once they're released, you rotate them slowly, 10 seconds for 90 degrees. Expect 10 to 13 turns and the bolts pop out when released.
Copy that. All right, I've got Alpha 4, counterclockwise 2, and really hard to stay clear of everything here that's white, of course. A little bit more of a challenge when you're not in the arm.
Copy, and those are good settings. You're good to go.
Okay, thanks. R1 is released.
Copy, good release on R1. Turn count?
That was 10 turns.
Copy 10, thank you. And Frank, just a heads up, around 12 minutes until we get to that eclipse, and you can start the work on the connector itself. Before that, we'd like to get a glove, half, and gauntlet check.
Okay, and work. There's 10.5 turns, and R2 is popped out.
Copy, Josh. Good release on R2. So when you're in a position, you can rotate those beam, those rollers. They're 90 plus degrees.
Copy. Nick, the only change to my gloves is on my right ring finger. I have a small little nick in the rubber. Doesn't go all the way through. Otherwise, no changes to my glove, dry hap, and gauntlets are down.
Copy, Frank. Thanks for the checks. And so you can go ahead, and we're going to put that short wire tie on the P23 cable with the 3 twists. So you're good to do that.
Okay, and work.
Josh Cassada moving the boom deployment mechanisms into the correct rotational position after releasing 4 bolts as a get-ahead task on the second set of ISS rollout solar arrays on the P4 truss, were earmarked for installation on the P4 truss of the International Space Station on December 19th, when he and Frank Rubio conduct their next spacewalk to augment the 4A power channel on the station.
And once you finish that wire tie, that's essentially what we're going to do, is just wait for eclipse, and then I'll give you the go.
Okay. And you want that wire tie on the cable itself?
And Frank, stand by.
The arms are swung out and move into R3.
Copy, Josh. We see a good config.
Okay. Give me settings for R3 when you have a chance. I know the term.
And Frank, you can put it on the cable above it that you're not going to demate. It's the small connector that's above. And Frank, back with you. You can put that wire tie on the small connector that's above the one that you're going to demate, so on one that you're not demating.
This is Mission Control Houston. A few minutes ago, Josh Cassada mentioned that he could see the Earth below and the Moon above him in his bird's eye perch. While working outside of the International Space Station, here's a real-time telemetry-driven animation of the Orion spacecraft and its distance to the Moon of about 42,000 miles as it prepares for its return-powered flyby. An engine burn that will occur behind the Moon on Monday morning at about 10:43 a.m. Central Time to propel it back around from the backside of the Moon on the final leg of the journey back to Earth, and a splashdown a week from tomorrow in the Pacific Ocean at 11:40 a.m. Central Time. Orion is functioning nearly to perfection. All of its systems in excellent shape as it exited its distant retrograde orbit. Our coverage of the return-powered flyby of the Moon by the unpiloted Orion spacecraft on the Artemis 1 mission will begin on Monday morning at 8 a.m. Central Time, 9 a.m. Eastern Time, through the return-powered flyby of the Moon. And we will have a briefing on Monday afternoon to discuss all of the particulars regarding the final major maneuver for Orion prior to splashdown. That briefing planned for 4 p.m. Central Time, 5 p.m. Eastern Time on Monday here on NASA television.
All right, Alpha 3, clockwise 3 for R3.
Affirmative. Good settings.
Awesome. Thanks.
And I said wire ties on Papa 10.
Copy, Frank.
You guys want me to drive some mid-strut bolts while I'm out here?
Thanks for the offer, Frank, but we're going to pass.
Copy.
Enjoy the view.
I am.
About 5.5 minutes away from entering an orbital sunset over the northeastern Atlantic, the International Space Station moving from northwest to southeast at an altitude of about 260 statute miles. Frank Rubio is at the starboard 6 truss of the International Space Station, and once we move into eclipse, he will demate one of 4 electrical connectors to isolate the affected area of the 1B power channel and that solar array that generates electricity out on the starboard 6 truss that experienced a power trip about 10 days ago, taking the 1B channel offline. The demating of that electrical connector will enable flight controllers here to reactivate the 1B channel and bring it back up to about 75% of its electrical output.
I'm taking a break. I think I'm at 140. Sorry. I'm trying really hard. And just confirm again, that was Alpha 3 counterclockwise 3.
Alpha 3, clockwise 3 for R3.
Sorry. Alpha 3, clockwise 3. That's what I've got.
Yep, and understand you got about 140 turns in. It's not possible to overturn this, and from your vantage point, you may be able to see the turkey timer come out when it releases.
I think I definitely will be able to see it, and thanks for the backup there. I'll keep going and make sure I get at least 245. And sorry, the collar moved, so I lost the backup there. The 140 is where I'm starting from.
And copy, Josh. And
you're watching Josh Cassada as he talks to Spacewalk communicator Nick Hague here in Mission Control. They are, Cassada is in the final stages of releasing bolts. The first 4 bolts for the other ISS rollout solar array that was delivered a week ago on SpaceX's mission to the station to deliver cargo. This iROSA that Cassada is working on as a get-ahead task will save some time on the next spacewalk the 2 astronauts perform on December 19th. This iROSA will move to the P4 truss of the International Space Station to be installed to augment power for the 4A power channel.
Hey, Josh, just watch your helmet with the that skirt hanging off iROSA. You've touched it a couple times.
Thank you for the heads up. I thought it was clear. I appreciate you backing me up there. All right, that's 200. Frank, how you doing out there?
I'm doing well. How are you?
Okay.
Counting. I hear you counting. I didn't want to say hi because I knew you were focused.
All right.
Okay, Frank, we are go for demate. So you're going to demate Papa 23 from panel 23.
Hey, Mark.
And Rubio is about to demate the electrical connector for the 1B power channel.
Hey, Papa 23 is demated from panel 23. I see good pins, EMI band, no FOD.
Copy. Good demate. So you are go to cap the saw cable Papa 23.
Copy inward.
Okay, that is over 245, and I see a turkey.
The demating of this electrical connector will isolate the portion of the 1B power channel and the solar array on the starboard 6 truss that experienced a power trip about 10 days ago, and enable flight controllers here to reactivate the 1B channel to about 75% of its working capability. Assuming no issue with the reactivation of 1B, this should eliminate the need for another spacewalk this Wednesday to clean up any work not completed today.
Yeah, we were in a handover. So, Frank, you were getting ready to mate, and I think, Josh, you had said you saw a turkey timer.
I do. I have a turkey timer on the left, and if you want, I'll go counterclockwise 3, alpha 3 on R4.
Hey, Josh, it's completely your call. We're happy to stop here and start working our way back in. Understand it's extra effort doing that free float.
I'll be honest, I'm here. I'd like to not come back. So if you don't mind, we'll just knock out R4 now.
Okay, copy that. So it's alpha 3 counterclockwise 3.
Alpha 3 counterclockwise 3, 245 turns, and I'm going to make sure that I stay clear of anything white.
All good words.
All right, next, so Papa 23 is demated. Both ends are capped, and the cable is on the short wire tie to Papa 10.
Yep, copy that, Frank, and got guys down here that want to make sure that we got to a hard stop on both those caps.
It did.
Copy. Great job. So you're good to translate back inboard to the tether swap location?
Great, copy that.
And Frank, it's a little tough for us to tell, but we just want to give you some heads up about your tether config. It may be going behind your back. Tough to tell because it's dark out there, but just a heads up.
Okay, I appreciate that. Let me get back to the IEA and I'll try to take a look.
Copy.
100. Nick, it is not wrapped around my back. It's just caught kind of on the other side of the PGT. But I can translate like this with it without any issues.
Okay, copy that. So you're heading back to the to do your tether swap.
Yeah.
And Frank, Josh, now that we've got all those connector ops done, we're going to try to turn on some external lights to help you out.
I appreciate it. All right, 245 was my count. The PGT says 243 and a half. Do you see a turkey timer? I'll throw a 1.5 on there for you.
And copy, Josh, you said you saw a turkey timer?
I do, affirmative.
That's a good release then.
I'm back at 2006.
Okay, Frank. You're gonna swap back onto your tether pack.
Copy that, and what?
Josh, thanks for the work on those. That's a huge get ahead. And so once you stow your PGT, you're going to go back and grab your crew lock bag in.
Okay, sounds good. And no problem at all. Fun stuff, even if you're just counting.
This is Mission Control Houston, 6 hours, 26 minutes into today's spacewalk by Josh Cassada and Frank Rubio. The two astronauts have wrapped up all of their work for today. The installation of the ISS rollout solar array on the starboard 4 truss to augment power for the 3A power channel on the International Space Station. It is up and running, generating electricity in excellent fashion. Frank Rubio recently, in the last few minutes, demated one of 4 electrical connectors at the starboard 6 truss for the 1B power channel that was affected hit by a power trip about 10 days ago, taking down that power channel. It is in the process of being reactivated right now by the electrical systems officer here in Mission Control. Once reactivated, it should be back up and running to about 75% of its power capability. It will receive in of its own an ISS rollout solar array next year, the next pair to be delivered on a future SpaceX cargo delivery mission. The two astronauts will soon begin cleanup work and make their way back to the Quest airlock to complete today's spacewalk. In addition, Cassada released a quartet of bolts as a get-ahead task on the next ISS rollout solar array to be installed at the station. That was sitting on a flight support equipment attachment device on the truss of the station. That get-ahead work will reduce the workload for Cassada and Rubio when they venture back outside the station on December 19th to install that next ISS rollout solar array on the port 4 truss of the station for the 4A power channel.
Okay, Frank, I am back at the port feeder cart and grabbing the M bag.
Okay. I'm just working on this. Unfortunately, this camera's getting in the way, but...
And before I get the M bag, you and I both know that cameras can complicate life. Do you need me to come help?
No. 1 second here. Not yet. Let me work this for a second.
Okay, I'm going to hang out. Nick, how much longer do we have in this night pass?
17 minutes.
Thank you. Nick, EV1 cooling is 3.5.
Copy 3.5 on your TCB.
All right, Nick, my red hook is on my right D-ring extender, gate closed, hook lock, black on black. And my reel is unlocked.
Copy, Frank. That's great.
I think you got it. Yep. All right, I'm going to...
All right, so Nick, with that, I can pick up my 55 foot, is that correct?
That's affirmative.
A 55-footer is picked up.
And Frank, when you're ready to pick up your local, you're going to translate inboard. Josh is in the process of putting the crew lock bag M on his BRT, and he'll lead the way back to the airlock.
Okay, copy that. And I see a good translation path, picking up my local, just cleaning stuff up a little bit. All right, Josh, I'm on my way. Sounds good. All right, I've got a BRT rep on the bag. I'm going to release the bag from the cart. Jaws are closed, paddles are out.
And Josh, real quick, looks like one of the door tabs may come open. Don't want all that stuff to spill out on you.
Thank you so much. And there's one more that wants to. We maximize the capacity of that bag or something. Okay. Thanks for that touch there. Round, and we got all four closed. Okay. Ready to the seat of spur, is that correct, Nick?
Hey, firm. You've got green hooks down. You'll pick up along the way.
Awesome. Thank you.
And Frank, as you're making your way over to your green hook,
So I'm over at the, go ahead.
Yeah, Frank, I was just going to tell you to hit the brake release on both of the seated carts as you're translating by them.
Okay, copy that. Okay, I've hit it twice on the starboard seat cart.
Copy, thank you.
That's 20 port feet across.
Copy, Frank. Thank you. I appreciate it.
Okay. That's great. With the carts, I've got my green hook and understand back to the airlock.
Copy, Josh. And Frank, looks like you might be a little inboard of your green hook.
Yep. Saw that. Heading back in. I think I have my green hook on my red reel. Both reels are unlocked.
Copy, Frank. It's a good config, and as you translate back by that port seated cart, if you could hit the brake release again for us, appreciate it.
Will do. I've got it twice again on that port feeder cart.
Copy that, Frank. Josh, see you down at the airlock. Frank's on his way in. Just thought I'd give you guys the general pulse of the control room, which is a bunch of smiling faces. People are super excited about how much we got done today. So awesome job.
Thank you so much. You got two giant smiles out here as well. What an amazing team. You guys definitely deserve your Sunday off, that's for sure. And Frank, what do you think? We maybe use this new station power to catch up on some college football.
Sounds good. The game's not till next week, but, you know, we can give our Go Army beat Navy today if we want to.
Wow. That wasn't my fault. I didn't know he was going to do that.
Taking notes.
I have to see this first.
Copy. Got a reel that doesn't really want to reel. Let's see what we got here. Nick, you okay with me opening up the thermal cover?
Hey, Confirm. You're good for the thermal cover.
Josh?
Hi, Frank.
Hey. Think you might hold a new record for most turns on a PGT in a single day?
Hey, that's right. Oh. Yes, sir. Nicely done, dude.
Well done, well done, well done, gentlemen.
Nick, with that, I can get on in. Is that correct?
Yeah, affirmative, and then we'll want to pass in crew lock tag M.
Nick, thanks so much.
Okay, copy that. I will drop my waist tether to the... Actually, hold on. So, Josh.
Yeah, go ahead.
How are we doing this? Are you going to pick up my...
Yeah, I think we're going to do reverse of what we did. I'm happy to pass you the bag now if that's easier to connect and send in.
Yep, give me a second. Let me just put in the...
And you're doing a waist tether with a Z-ring extender, is that right?
Yep, and gate closed, hook lock, back on back.
Perfect.
And Nick, once I have that and I'm in the airlock, is Josh just able to release my... Oh, well, you're going to have to release yours anyway, so never mind.
We'll talk us through it. It's been a long day, for sure.
Yeah. And I am ready for that bag.
Okay. I'm going to take it off my BRT, but it's still redded to my BRT, right?
I'll read it to the inside, and then I'll take it off and pass it back to you.
Sounds good.
All right, Josh. You ready for your rep?
I'm ready.
Okay. Come to that.
Got it.
All right.
And guys, the next step would be for each of you to turn off your HECA.
Okay, that sounds good. That's before I make the tether connection. Is that right, Nick?
Yeah, I'd like to get you. Yeah, Frank just turned off his HECA. If you can check and turn off your HECA, and then Frank wanted to check your waist tether that you've got to the airlock D-ring extender, the small hook on your waist tether, just to make sure that that's locked.
Yep.
I can take a little hook lock, back on back.
Copy. And so, Josh, when you're ready, you're going to go to release Frank's anchor hook from that port stanchion of 554 and put that on your waist tether.
Copy.
This is Mission Control Houston, 6 hours 45 minutes into the spacewalk. Back at the Quest airlock, you can see Josh Cassada as he begins to stow equipment that he and Frank Rubio used for the successful installation and deployment of the ISS rollout solar array on the starboard fore truss of the station, which is now generating electricity to augment the power output for the 3A power channel on the International Space Station. The crew also disconnected or demated one electrical cable on the 1B power channel on the starboard 6 truss of the station to enable flight controllers here to reactivate the 1B channel, which has been down for the past 10 days. It is in the process of being reactivated back to about 75% of its capability.
And close the thermal hatch.
And Cassada did a few get-ahead tasks as he unbolted 4 bolts on the flight support equipment holding the next ISS rollout solar array in place that he and Frank Rubio will install on the port fore truss of the station on December 19th during their next spacewalk to augment the power for the 4A power channel on the complex.
Yeah, being ring. All right. Okay. Full cover is coming.
Copy, Josh. And so you'll attach the hook to that magnetic plate D-ring, cinch the strap, and report the number of lines visible, expecting 6.
Okay, welcome. Frank, is that you there? Yep.
And 10 seconds from a handover.
The thermal cover on the Quest airlock being closed.
You're able to go to station.
And a view back inside the equipment block where Koichi Wakata and Nicole Mann will be in attendance shortly to begin the work to help Cassada and Rubio back inside once they return to the crew lock section and repressurize the crew lock at the start of repress. That will mark the stoppage of the clock on the phased elapsed time for today's spacewalk. Once we have repressurized the crew lock section, the hatch will be open between the crew lock and the equipment lock, and the two spacewalkers will be helped back inside the equipment lock to begin an inspection of their gloves, their helmets, before they doff their helmets, and that will wrap up our coverage for the day.
There we go. All right, it is cinched, and I've got 1, 2, 3, 4, 5, 6 lines.
Copy, Josh. 6 lines. So you'll both remove your SCUs from the stowage pouch uncover your DCMs, and then connect to the SCU.
Copy. Copy. Inward 3V1. Paper 2. Frank, if you could, your pouch, if you could attach that to the wall, it's trying to get into the hatch. Oh, rush. My pouch, okay. You're saying, move it up here? Yeah, there's Velcro on the wall. Okay, I'll just hold it up here. No worries. Oh, I see it, yep. Okay. EV1 SCU is connected. EV2 SCU is connected.
Okay, copy that. And so with that, you are both go to switch your water off. Expect the H2O off message.
Water's coming off for EV1. Water's off EV2. It's off for EV1. Off for EV2.
And copy, off for both of you. And so we're going to sit here and wait for 2 minutes before we can close the hatch. I may have missed it during the handover, Josh, but can you confirm on the thermal cover that the magnetic, the magnet's attached?
It is not. It doesn't stay. We are cinched down 6.
Copy. Do you see anything between the magnet and the plate that would prevent it from staying put?
Now that I'm looking, we should probably get rid of this flap. It is connected. Thank you for backing me up on that. I appreciate it. The flap
no
is
problem.
out of the way, and the magnet is connected.
Copy, thanks. And we're just going to wait for those 2 minutes to elapse.
Frank, I'm going to just start getting in position for the hatch. Yep, you're fine. You have all the room. There is something on my back. You know, is that a bag?
And Josh, as you're moving into position, yeah, you're just confirming that the hatch is going to be clear of any kind of hardware and that the handle's in the position per the hatch decal.
Sounds good, and I'll take care of that handle in the right position when I've got it in a better view. There's nothing obstructing the hatch right now.
Copy all.
Inside the equipment lock section of Quest, Nicole Mann on the right, Koichi Wakata on the left. They were in charge of Canadarm2 robotic operations during today's spacewalk, moving Josh Cassada around as he maneuvered the ISS rollout solar array from its flight support equipment attachment point on the truss of the station over to the starboard fore truss, where it was installed, bolted into place, and ultimately unfurled to its full length of 60 feet. Now they are standing by, watching and waiting for 2 minutes to transpire before the hatch is closed to the crew lock section of Quest. That will be the precursor to the start of the repressurization of the crew lock that will stop the clock on today's spacewalk elapsed time.
Copy, thanks.
Okay. Can you move that bag that's on my back there? You have a chance.
Okay. It's over by your feet now.
Okay, thanks. There we go. All right, so I'm going to position the handle in the unmatched direction. Handle's currently at 2 o'clock. I think I need about 8 o'clock next, and just confirm before I put it in place, it needs to go in the unmatched direction, correct?
Affirmative, Josh.
Just like it. Awesome, thanks. All right. You are latched and locked.
Copy, Josh. Understand lacked and latched and locked on the hatch. I've only got 7 hours on this mouse. Well done. Hey, Flight's got a few words for you.
Hey, for Frank, Josh, and Guichi and Duke, I just want to say that this is the kind of day that makes you want to clap your hands. And to the station, we bring new power, more power generation restored on this EVA than ever. So let MCC be heard to the ISS. Let there be light. Great job. Come on in.
Wow, that is overwhelming. You guys are incredible. Thank you.
Okay, Frank, let's finish up this pre-repress cue card. So you're going to, on the UIA, you're going to check that oxygen for EMU 1 and 2 valves are open.
Oxygen, EMU 1 and 2 are open.
You're going to power EV 1 and 2 to on. Check that you've got the LEDs and volts.
Copy. EV1 power is on, good LED. V2 power is on, good LED. 18.
This is Mission Control Houston. Those congratulatory words from Flight Director Zeb Scoville, who is the Deputy Chief Flight Director of the office here at the Johnson Space Center. Now Josh Cassada and Frank Rubio in the final stages of preparations prior to the repressurization of the airlock.
One is in at CU.
Copy,
CU.
See you.
Copy.
And copy, Frank. Josh, you're both in SCU. So with that, I'm going to hand you over to Duke and Koichi to pick up with the crew lock repress.
Thanks so much. Don't turn your phone to silence. We're giving you a shout in just a half hour. Be both you and the whole team. Thank you.
So much, Rick.
You bet. Awesome working with you.
All right, Blue and Frank, welcome back. Let's get you inside. You can both take your O2 actuators to press.
All right, in work for EV1.
Thanks for you too.
Good to see you with that SCU.
Yeah, it really is.
Everything's backwards in my mirror. Okay, B1 is in press.
EV2 still working? Yeah, I'm in press.
Okay, copy, both in press. One, can you check that the EV hatch MPEG is closed?
The EV hatch MPEG is closed.
Okay, we're going to throttle the IV hatch equalization valve off to norm. Let us know if we need to adjust the rate.
Sounds good. Thanks, Duke.
This is Mission Control Houston. The repressurization of the Quest airlock is now underway, ending today's spacewalk at 1:21 p.m. Central Time, 2:21 p.m. Eastern Time. Today's spacewalk, 7 hours, 5 minutes. Again, today's spacewalk ended with the start of the repressurization of the Quest airlock at 1:21 p.m. Central, 2:21 p.m. Eastern Time, bringing today's spacewalk to an end at 7 hours and 5 minutes. We'll have complete statistics for you here shortly.
Station Houston 2 for airlock EV2 please, Frank, please check your O2 actuator in press. And if you need to, stop the repress in the meantime.
Say again?
Stop the repress.
Yeah, stop repress, and Frank, we need your O2 actuator into press.
Affirmative, I see it in press, and my ECN said O2 actuator was in press.
We're showing it in off, OFF, needs to be press.
Okay, copy. There you go. Okay, O2 position press.
Okay, copy, go to resume repress.
Okay, at 4.0, you can expect another alert tone.
Copy. Copy.
Okay, we're at 5.0. We're in the 2-minute wait.
Sounds good. You too, copy.
This is Mission Control Houston. You're looking at the equipment lock section of the Quest airlock. Koichi Wakata of the Japan Aerospace Exploration Agency and Nicole Mann from NASA on the right, as the repressurization of the crew lock section of Quest well underway, going back to its normal pressure of 14.7 pounds per square inch, at which point Wakata and Mann will open up the hatch and bring back inside the equipment lock Josh Cassada and Frank Rubio following their spacewalk today. Here are today's statistics following the completion of the extravehicular activity. This was the 256th spacewalk in support of space station assembly, maintenance, and upgrades. The 11th spacewalk conducted out of the ISS in 2022. The third spacewalk during Expedition 68. For both Cassada and Rubio, it was the second spacewalk of their respective careers, both totaling 14 hours and 16 minutes of spacewalking time. The 256 spacewalks for International Space Station support have now totaled 1,623 hours and 18 minutes, which is the equivalent of 67 days, 15 hours, and 18 minutes of spacewalking time. And the 3 spacewalks for Expedition 68 now have logged 20 hours and 41 minutes. So we'll be standing by for that repressurization to be completed, for the hatch to be open, for the 2 spacewalkers to be brought back inside and mounted on their respective sides of the equipment lock, where photographs, as usual, will be taken of their gloves and suits before their helmets are doffed.
V1 is in IV. EV2 IV.
Copy. We are resuming the repress with the hatch equalization valve. You can expect an alert tone, and when DPDT is about 0, you'll get another tone.
Copy. Copy.
This is Mission Control Houston. Koichi Wakata and Nicole Mann of the Expedition 68 crew on the International Space Station, watching the final moments of the repressurization of the crew lock section of Quest before they open up the hatch right in front of them and bring into the equipment lock Josh Cassada and Frank Rubio, who aced their spacewalk today, installing the ISS rollout solar array on the starboard fore truss, electrically hooking up that array, which is generating perfect power to augment the power output of the 3A power channel on the International Space Station. Also disconnecting one of 4 electrical cables from the 1B power channel on the starboard 6 truss to isolate a portion of the solar array on S6 affected by a power trip about 10 days ago that took the 1B channel out of commission. The 1B channel is in the process of being reactivated as we speak to about 75% of its operating capability. Also, Cassada did a few get-ahead tasks, including the unloosening of 4 bolts on the next ISS rollout solar array that is on a flight support structure on the truss of the station, and which will be moved by Cassada and Rubio to the port fore truss of the station and installed and deployed to augment power for the 4A power channel during the next spacewalk the 2 will conduct on December 19th. And the hatch is now open between the equipment lock and the crew lock, as Nicole Mann will now begin work to bring in Cassada and Rubio.
Houston, I see that you're taking care of step 4 and 5. We'll move along to step 7.
Concur, we're putting it in work.
Frank Rubio back inside. They will first work to remove the jet-powered backpack, the SAFER unit, Simplified Aid for EVA Rescue unit, from his extravehicular mobility unit. Again, today's spacewalk registered in the history books at 7 hours and 5 minutes in the installation of the next in the series, the third in the series of ISS rollout solar arrays, now up and running and generating electricity for the 3A power channel on the starboard fore truss of the International Space Station.
Station Houston on Space to Ground 1. Steps 4 and 5 are complete. You are no longer hotline.
And Josh Cassada back inside the equipment lock. Frank Rubio on the left, Josh Cassada on the right, being attended to by Nicole Mann, with Koichi Wakata also working in this post-spacewalk time frame. The spacewalk ending at 1:21 p.m. Central Time, 2:21 p.m. Eastern Time at 7 hours and 5 minutes. A completely successful spacewalk for Cassada and Rubio to install the third in the series of ISS rollout solar arrays, the iROSAs, to augment power capability for the International Space Station. And here is a replay of the actual rollout of the iROSA after it had been installed on the starboard 4 truss of the International Space Station. It took about 9 minutes for the array to roll out to its full length of about 60 feet. The electrical systems officer here in Mission Control then worked to power up the array. It was generating electricity almost from the get-go and is reported to be in full electrical generation capability. Nicole Mann working to remove the gloves from Josh Cassada, as Koichi Wakata does the same for Frank Rubio on the left side of your screen. Soon they will doff their helmets. That will wrap up our coverage for the day. And the helmets are off. Cassada and Rubio safely back inside the equipment lock of the Quest airlock of the International Space Station, a 7-hour, 5-minute spacewalk in which they successfully installed and deployed the third in the series of ISS rollout solar arrays on the starboard fore truss of the International Space Station. It is up and running in good shape, augmenting power already for the 3A power channel for the International Outpost. These two will venture back outside on December 19th to replicate the feat with the next ISS rollout solar array that they will install at the P4 truss on the other side, on the port side of the International Space Station, to augment power capability for the 4A power channel. So that'll wrap up our coverage for the day. Two programming notes. While all this activity is going on, the Orion spacecraft is barreling back toward the moon, heading for a return-powered flyby of the moon coming up on Monday, December 5th. Our coverage of the return-powered flyby burn that will take place actually behind the moon and enable Orion to whip around the moon and head back on its final leg of its 25-and-a-half-day mission, with a splashdown scheduled on Sunday, December 11th in the Pacific Ocean. Our coverage of the return-powered flyby burn for Orion is slated to begin at 8 a.m. Central Time, 9 a.m. Eastern Time on NASA television on Monday morning. That will be followed later in the day at 4 p.m. Central Time, 5 p.m. Eastern Time, with a briefing to wrap up the return-powered flyby and to preview recovery operations that will begin in earnest with the Exploration Ground Systems folks from the Kennedy Space Center out in the Pacific Ocean later in the week. So that'll wrap up our coverage for the day, a spacewalk that registered 7 hours and 5 minutes. Josh Cassada and Frank Rubio back inside the International Space Station, their next spacewalk scheduled for December 19th. For now, that'll do it for us here in Mission Control. Have a great weekend. Thanks for watching. This is Mission Control Houston.